One sec. Okay. Yesterday was a trip, huh? So what I did learn after yesterday. Oh, by the way, we can run Sponza pretty well now. I did do some work on things, and we can bake Sponza, but it is still kind of buggy, and it does take a long time. And you know, in thinking about it, and also I asked Jarvis, "Hey, am I stupid in making my CPU lightmap baker? And what should I really expect from it?" And Jarvis said, it's performing just as it should, and that if I wanted to be serious, then I should do it on the GPU. The amount of time I'm probably gonna save by moving it to the GPU now is so much that it's necessary for me to do. I'm gonna save like so many hours of my life by doing this now instead of later, even if it's going to be a legendary pain in the ass. Like a legendary pain in the ass. I've written my fair share of compute shaders over the past year. I've written a lot of compute, but this is probably going to be the hardest thing. Probably a bit harder than the Radix sword for the Morns and the LBVH and all of that stuff. I can imagine it being harder than all of that to some degree. So apparently from the quick overview that I got about what I need to do is fairly complex, and also not like something that I've done before. It's going to involve a G buffer, which I've never done before, which is an interesting concept. I've never done it, but basically the idea is to image store. Okay, so basically we're gonna have a 2D frame buffer like we would for drawing, right? We project the lightmap UVs onto that, and then write in different textures, the position, the normal, and the material ID, triangle ID, and the mesh node ID of each texel in a fragment shader to that texture. And then when we start, iterating and doing the rest of it, then we use that texture's data to do it in compute. But I think the hardest part is going to be debugging the first initialization of that texture, because I've never done anything like that before. Hey, good day, my name is Kevin, making a video game engine in C++ out of sky scrolling geometry collisions. That's awesome. Is it 2D based on the scrolling thing? That's really sick. I did a bit of sky in my last project. It was atmospheric scattering, so it was like real time. Like it was a space sim. So when you went down to the planet, the atmosphere, came over you, and it went from like the dark blue ozone to the light blue sky and stuff. And that was a lot of fun. That was like probably some of the most fun I've had doing graphics programming. Thanks to Arya for making me do that. Okay, so we're gonna start off by not doing any of what I just described, because I think that the adjacency map needs some work on it, because it's not detecting some adjacent faces because of floating point precision things. So what I've decided here is to basically make it so that you divide by a really small number, make it make the numbers bigger so that they then floor out to about the same ballpark, these indices, so that they match, and then base the adjacency map off of that. However, not very easy to do so. Not very easy to do so because we need a second hash table to do this, I believe. So let's actually think about what's happening here. So we need to make these keys that are the exploded integer space keys before we do the iteration for the actual edge pairs, which is how we determine adjacency between triangles. Is we have these edge pairs that we compare, right? But we're not going to do indices because those indices might be pointing to two different vertices that just aren't connected, but they're in the same spot. And so what we have to do originally is get those vertices matched up and then move the indices over. So yeah, that's that, right? So each index on a face maps to an index that goes into this tri-array, and so we need to match all of those indices to something else, to these keys. Let's think about this. Yeah, I think we need another hash table, unfortunately. I was trying to figure out a way to get it without it, but I think that we just literally do need a hash, another one, because we need to check for duplicates, obviously. For duplicate vertices. Okay. So we actually want to go by vertices here. I was wrong about that. But we will, unfortunately... Actually, yeah, don't calc this. Instead, let's calc index map. For each vertex to map into the welded one. Okay. Okay. So now that we get a key, we need to check the hash table. So that's going to be just the hash find in the EP is the one that I was using for indexing into it. So this is actually just going to be key. And then we want to get a I think you do it like this. And then if we found an entry with the same key, else we create the entry. If we find the entry with the same key, then we want index map index by I equals whatever the index of that entry is. So I think we add onto here, have an index on it that we then set this to. If you want to continue a demo of the engine, you can tell me what you think. Yeah, sure. If you want to send me in on Discord, I'll be sure to look at it later. I was like checking out people's projects. Okay, so if we find an entry in the table, we need to assign it to that entry's index. I think that's fine. Otherwise, we want to add it to the table. This is just one of these things where I needed to get done before we could move on to the other stuff. Yo, what's up, Sophie? Sorry. Index equals I. Okay. And the key will equal key. And we don't have to do any of that. And now we just hash add the welded vertex key. Let's see, and the key hash add incompatible pointer type. This is welded table. Incompatible pointer type, edge pair entry. Why? Oh. You set up SSH properly today? That's cool. What do you mean by properly set it up, though? Now, unfortunately, we need to delete this table as well, which is kind of a pain in the ass. I'm not gonna lie. We need to get these two for welded entry. Pointer. I'm just gonna use S0 and temp 0. Incompatible pointer types again. Oh, S0, temp 0. And then we shouldn't have to do anything else here. Oh, maybe we do. Sort of SSH agents. What do you mean by agents? Don't tell me you've gone to the dark side with the AI shit. I don't know anything about SSH, so I'm just ignorant, so. Okay. Okay, so how do we do the rest of this? Now, instead of going f indices j, we will go the index map. Oh, also index map I equals I believe. Like, you input that your private keys and then it manages them when talking to stuff. Oh, I see. So what is it used for, though? To talk to stuff? The rest of this shouldn't change, right? Get, for example. I see. Yeah, I always have to do the fucking shitty key thing. I hate that. I hate it so much. I fucking hate that so bad. That shit is so fucking annoying. Oh my god. I just got mad thinking about it. About having to input the fucking key and then storing the key, and you know, fuck that, dude. Go as tries count for j. If I equals j, continue. Indices j, continue. What is try indices? As tries. Oh, the adjacent tries. Oh, okay. So it shouldn't matter. Okay, is it time to see if I did this correctly or if I did this fucking stupid shit way? If I did this the stupid shit way. Let's see. Codeberg banned LLM assistant content. What does LLM assisted content mean? Like, if you use fucking AI to like be like, yo, can you help me with this problem? Are you just fucking banned? Or are we talking about like, if you use LLMs for your code? Yeah, but like, what is the spectrum? What is the spectrum? Because that's like, you know, I don't know. Like, if you use codecs or whatever the fuck, like, that's on a thing, but it's like, I don't know. Why does this not work? I think that this wasn't working before, actually. The UV island thing. Ah, shit. Yeah. Yeah, whoops. Whoopsie daisy. Yeah, we should probably not be testing this on Sponza. Or maybe we should be. It just takes too long to fucking bake. Let's use demo scene. I don't know. I'm pretty sure everybody by this point has at least like copy and pasted one fucking, function from ChatGPT or whatever. That's like pretty whatever. It's the same thing as using Stack Overflow for like certain things. So banning all AI assisted code is like, I don't know, that's like kind of impossible to do. Why does this not have collision? I probably broke the adjacency map, that's why. Ah, shit. Well, that's not good. That's really not good. That is really, really, really not good. It may be fucking cooked. Let's just try not using the index map and then see if that is 100% what it is. I'm just gonna guess that it is. Yeah. Shit. Well, my idea is a shit idea, apparently. Well, it's not a shit idea, I just probably did it in a fucked up bad way. I'm probably doing something with the hash add wrong or something. How about this? What if I just do this, which should theoretically just be always mapping it to the same place? Oh, also, I should really just be using the saved map for this. Okay, well now you're just pissing me off. Okay, so that works. Okay, so why does this I might need a bigger epsilon or something. Let me try a bigger epsilon. It may be matching things that shouldn't be matched, I guess. Okay, that works. That works. Okay, but that doesn't work. See, that's exactly what I was worried about. That was exactly what I was worried about. Actually, hold on a second, because we didn't actually bake, so we were using the old map with different UVs, so theoretically that might actually be fine. Let me just generate it with really low values, just so that we can see. I don't know why I can just fly through the wall, but yeah, see, this is the problem. I mean, then again, we don't have a lot of razor iterations, so it's like hard to tell. It is hard to tell. And we don't have a blur. But it's like, it takes forever to bake it. So it's like... Yeah, the blur on this takes forever because there's a lot of fucking surface area. There's a lot. But I needed to run it to see this. I probably shouldn't be doing this right now. But I wanted to work out the last few bugs before moving it to the GPU, because once I start with that, then I don't want to be misinterpreting bugs. Like, when there's a bug with that, I want to be absolutely sure that it wasn't a bug with this, you know? So, I have to do this first before we have to debug the rest of this shit. I frothed my fucking coffee foam way too much. It's just stuck at the bottom of my cup. Shit's fucked up. Shit is fucked up, bro. I've been fucking with sparkling water lately. It's pretty good. I used to hate that shit. I used to hate people that like have like LaCroix in their fridge or whatever the fuck. That used to piss me off. Fucking rich people soda, bro. Yeah, I used to have a real hatred for the rich people, like, health drink thing. Like the nakeds and the... I don't know. Rich people have such a hard-on for, like, being healthier than the rest of the population, you know? Shit used to piss me off. Now, not so much. Oh. Looks like it works fine. Collision looks fine. I don't know, like, sometimes you get stuck on the floor like this. With my code. When you're flying around. I mean, it's only when no clipping, of course, but it's my is on ground logic, you know. Sort of ties you to the surface. Yeah, this looks fine. Hey, what's up, Anna? I was working on the on working a few of the bugs out before I move it to the GPU. I made my adjacency map based on integers instead of floating point. The keys, the hash table keys, so that they don't have collisions based on floating point imprecision. I did turn the, so you know what happened is that I turned this asset around in Blender, and then I was doing that, but then what happened was that I named the lightmap file exactly this name, and then overrode the file. So then I so I haven't you know, been not lazy enough to flip it around again, because I overrode the file with my fucking lightmap name. So that's why it's sideways still. Your model looks great. Yeah, it looks really cool. I wish it wasn't upside down though. I like actually having it this way, because then you can do like the shit like coming in through the window. I forget what direction it is, but it's like that. That. It's something like that. Okay, I got it after some fucking with it yesterday, but anyway. I don't know my directions, obviously. This is going the other way. This is going that way. There we go. There we go. There we go. It looks cool sideways though. Yeah, I like how you can see the balls from outside, yeah. Anyway, I think that figured out. We did have to use an epsilon of 0.0001, which is really small, but you know, if the shoe fits. Something else I want to do. So I asked, because I was confused, I asked Jarvis, hey, this couch crashed me yesterday, and there was a seg fault, and I think it's infinite recursion, but I need to figure out what happened. And Jarvis said, saw the exact line of code that I crashed on, and said that's a Stack Overflow. And I've like never gotten a Stack Overflow like this before, because it's not even using the stack. But I'll explain what the problem is. So the problem is that I have this array. When I'm creating UV islands, I have this array of all of the triangle indices that have been that have already been that have already been assigned to UV islands, so that we don't reassign them. This is a completely, normal thing to do. But what happens if you have 71,000 triangles? Well, that's a lot of memory. And I didn't really think about that, because when I made it, I wasn't obviously doing 70,000 triangles on one mesh, But yeah, apparently that was my problem. Anyway, the very simple way to fix this now is to just make it booleans and not have a vector, this trialist vector. Instead, we should just malloc this to one fucking thing. Just have it so my idea wasn't wrong. It was just you know, I don't know why I didn't think to do it this way, because this is obviously the smart way to do it. But you know, sometimes you live and you learn. It does look cool sideways, yeah, it does. Okay, so now we have this try list, and so instead of doing this search, what we can do is just if try list I continue. I don't know why I didn't do it that way. I think I was writing this. I wrote this on stream, and I didn't really think about it. I just wrote it real fast, and I just wasn't really. I don't think I was in like a great headspace, but this, you know. Anyway, I kind of want to load the couch now when I fix this. I wonder why I did it like this. I think that there was probably a reason for it, and then once I got to the end of it, I didn't need this anymore, and I didn't think about it. But there was definitely, like, while I was going through it, I had like this try list idea in mind, where each UV island would use its try list at the end and shit like that. But obviously we have this island tries, which already fills that purpose. So this try list is actually just completely unnecessary. But I didn't really think about it after some point, and we obviously suffered yesterday because of the fucking couch, you know? So my bad on that. What the fuck? What does it sound? Weird. Sometimes there are creatures that get put on the window, like lizards and shit, and then they make noise. And it scares the fuck out of me. I think I'm gonna start being smart and do allocations like I should be, which is like this. Although you would already segfault by now if that doesn't work, so that's actually fucking pointless. So just have enough memory, dumbass. Anyway, let's test this out. Let's use the lightmap that we already computed. It should be one-to-one the same code, just faster, and less stupidly a lot of it. Now I kind of want to load the fucking couch, to be honest. But I feel like you know, we're in a good mood. Why try and load the couch? I should just move this to the GPU already and stop fucking around. I want to see how long it takes. Just estimated. Well, this isn't actually that long at all. Doing the GPU stuff is just dreadful, yeah. I asked Jarvis for like an overview of everything that I need to move over, just like a bullet point list, and it gave me this is everything that I need to move over to the GPU to do it. And put in SSBOs basically. So something that I didn't like think before, and I don't know why I didn't fucking do this, is the inverse. Like, why didn't I just pre-compute the inverse matrices and cache them? Like, what the fuck is wrong with me? But yeah, once I read that, I was like, oh, yeah. Why didn't I think of that? I was doing them on the fly. So, yeah, I'm just dumb. I don't know, sometimes I just write code and then I like stare at it and then I don't see the optimization. You know what I mean? I used to inverse image shaders on the fly. I see. Yeah, my lightmap baker does it on the fly, yeah. Which is stupid. Oh, Slang didn't support inverse. Okay. Is there a reason? Oh, wait, that was just the UV islands. Oh. 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 I didn't register in my mind that was just the UV islands. So, okay, we're not doing this again. We're not fucking doing this again. I was like, wow, this is surprisingly going fast. But that was just the UV island initialization. Yeah. Yeah, I don't think so, buddy. I don't think so, buddy. We're not baking this for an hour again. Fuck no. Fuck no. Yeah, they are expensive to compute. 64 bits is enrolled for my testing edition. Voxel experiment. Okay. Yeah, but for this though, I mean, you just send everything at once, and then you just, if you can avoid matrix, yeah, I mean, definitely, it's not cheap. It's not cheap, yeah. But I just sometimes I just write code and then I just don't see the obvious optimization, because like in my mind, right, it's like, oh, but if I cache them on the struct, then we never know when we made the last inverse, and what if the object is moving, and you know, you kind of just like get stuck in your head about it. But for things like obviously lightmap baking, you can just pre-compute them once. It's not like they're moving in real time anyway. Yeah, inverse is, I know that inverse is expensive because, for example, my inverse. No, let's look at the actual column major inverse that I have. This is what the function looks like on the CPU. This is the function for the inverse. That's the inverse. Are you seeing this? That's what the inverse is. That's the code. Some Tokyo Swift, yeah, I like Tokyo Swift. Now, where did I get this? Stack Overflow. Anyway, yeah. So I'm well aware that they're expensive. Yeah. The good thing about the GPU though is that the GPU does it like so optimized. You know, like obviously in GLM they also do it like with simmed and stuff, so it's way faster than mine. Thankfully, that one always worked for me. Okay. So I did talk with Jarvis, and it said that the fundamental starting point, right, is that you have a frame buffer. You have a frame buffer that becomes the lightmap, and you just draw to it first, like a G buffer. It's a G buffer, and so this is what I made for the G buffer. Is you have the position, the normal, and then the 3 IDs for the material, the mesh, and the triangle ID in one thing. And then so this is a G buffer, right? So you're basically drawing a G buffer on top of the lightmap that then in your compute shader you just start at each texel and read from the textures what the values are. And apparently the good thing here is that it automatically does the interpolation, so you don't have to do barycentrics. So if you just write for the lightmap UV out, these are varying, so it already rewrite in Rust. No, it already interpolates it for each texel, right? So if you have a triangle that spans 3 texels, this already interpolates all those texels for you. So basically, what I had to do for the lightmap on the CPU was I had to do these barycentrics, which is how I did it in my old engine, right? So you compute the barycentrics, and then you emit all of the triangles based on their UVs. So it's free on the GPU. They do this for you. You don't have to do any of this. So it's technically easier. What isn't easy is all of the architecture that I need to do in terms of SSBOs to get it on the GPU. And also, I need to figure out I need to move over all the ray intersection tests and all of the BVH traversal. That's going to be the bad part, right? Is that I have to write all of that on the GPU. The BVH traversal is going to be the big thing today that I have to work on. The rest of it, not so bad. But yeah, that part is gonna be fucked up for sure. Because my BVHs aren't linear, like it's not an LBVH, so traversing it requires recursion. So I'm just gonna do the stack pointer thing that I was talking to you about. I'm gonna have a stack pointer, and then push onto the stack with the new nodes and all of that. Obviously, you have to have the good thing is I'm not going to do the BVH build on the GPU. Already been there, done that. It's way more work than it's worth if the BVH isn't in real time. For now, all I'm going to do is I'm going to build it once on the CPU, send it, and then traverse it on the GPU, because this is just an offline lightmap baker. So, and just having that on the GPU, if I want to make it real time on the GPU, then I can. It's way easier to do that later when I have all of the traversal stuff already on the GPU. But putting the build on the GPU, that's going to take like 2 days for me to code that, for sure. I mean, it's going to be 1-to-1 with my with my build on the CPU, but it's still a pain in the ass, you know, especially if I want to do an LBVH again and then I have to put the radix sort stuff over. It's offline. I'm not going to worry about it. Anyway, so Jarvis made me this list earlier of everything I need to put in SSBOs. And so that's what we're going to do. We're going to start by putting everything in SSBOs. I'm just going to BCO and then we can get started. Okay. init.h is where we have all of our SSBOs, so we need a few here. Because of the unsized array things, I'm sure some of us know here what I'm talking about with Intel unsized arrays. Those are two words that are just spark horror and fear into all of us, you know. When it comes to SSBOs on the GPU, I'm sure all of us understand the padding and alignment issues that come from not using unsized arrays. Certain GPUs, especially older GPUs, hate sized arrays on the GPU when it comes to SSBOs, and so we're gonna have a lot of SSBOs here. That's unavoidable. I would love to just put it in one, and you know, it would be lovely. But unfortunately, I've shit GPUs, and therefore we have to make quite a few SSBOs here, each for the different purposes because of the unsized array issue. So that's going to be, I'm sorry to let us all down here, but that is what needs to happen. Okay. I don't think that each of these needs to be their own, though. We can have one for per mesh data, and then try to do that. But the thing is, then... Oh yeah, this is hard. If for those of you who don't know here, the limitations of GPU memory is you can only have one unsized array per SSBO. And it has to be at the end. This is tricky here because our meshes, of course, can have as many vertices or triangles as they want. So there are a few ways we can go about it. This is going to be hard. What I'm going to suggest here is going to be very difficult to implement, but I think it's the only way forward. What we're going to do is we're going to unwrap each mesh. We're going to unwrap each mesh into a flat array of vertices and a flat array of triangles. And we will remap the triangles to the unwrapped vertices. That's what I'm going to do. Okay? And then in a third SSBO, we will have metadata for each mesh. For each mesh, we will have start triangle, end triangle, start vertex, end vertex, and the matrix transforms, and things like this. Okay, that's what we're gonna do. It's not gonna be easy. It's gonna be very hard. So we will have a vertex SSBO. By the way, why I'm doing this is because my GPU really doesn't like sized array and really doesn't like arrays, you know, padding big arrays. Really have had some trouble with it. So this is what we're going to do. A vertex SSBO, a tri SSBO, a mesh SSBO. And the mesh SSBO will just have an unsized array of meshes with each one inside of it will have that metadata that I just talked about. Then we want the mesh BVH SSBO. We want the scene BVH SSBO. And we want that instances goes into the mesh. The material data. Ooh, interestingly enough, we already have this material SSBO. I'm hoping that we can just repurpose that. And then this one, this texel data will be in the texture that we already talked about in the G buffer. Okay. Okay. And this kind of maps one-to-one with this kind of. What's up, Freaky Diddler? Okay. How are we gonna fucking do this? How are we gonna fucking do this? Well, I think a good place to start is by just simply starting with some of these what is lightmap GPU? Oh, that's something else. We need to start with the types. So let's just do all of the GPU types for the SSBO data. We're going to start with Vertex SSBO. Vertex GPU. How many lines of code in this project? I don't know. I have no clue. The lightmap file is a big one, 2K. The mesh file is 2K. The editor file is 500. The GJK file is 1K. The we got a lot in here. The acceleration file is 2K. The oh my gosh, it just broke. What the hell? What? What the fuck? It just broke my shit. Well, okay, we're not going to go down that rabbit hole anymore because it literally just broke my fucking computer. So anyway, there's a lot. There's probably like I'd say like 15-20K so far. Hi, Anna. Anyway, I'm just planning what I'm gonna do. I'm going to have all of these different SSBOs. So we're gonna have one for the vertices. We're going to have one for the tries. We're gonna have one for the mesh metadata. We're gonna have one for the mesh BVHs. One for the scene BVHs. And one for the materials. Now you may be saying, why not just have one for all the meshes? Well, because then we have to have a maximum try and vertex count, and I don't want to have a maximum try and vertex count. Unfortunately. Unless I want to inject into the shaders the number of tries on initialization. But I don't know how to do that. How do you even comprehend this type of code? A lot of time alone in a fucking room. You know? When you spend enough time doing something, it doesn't really matter, you know? So all of these are gonna be unsized arrays, right? So we're gonna unflatten every meshes triangle array into, or flatten every meshes triangle array into just one massive array. Same thing with the vertices, and then remap them. And then this will be the mesh. It'll like be try count and the matrix and that stuff, and then it's gonna be the BVH for each mesh. This will need a top. This will be a top. Have to have a max amount of nodes, unfortunately. Do you know how to deal with that? All right, peace out. Let me actually look this up. I don't know. I think. No, yeah. Don't worry about it. Don't worry about it. I deserve way more views because this is insane. There's a lot of people that do insane stuff. You know, you'd be surprised. Just a lot of them, you know, aren't loud about it. You know, just like think about like the fact that Terry Davis got famous or whatever was just like, you know, just pure like a weird thing that happened. You know what I mean? There's like, do you know how many like Terry Davises I've like met in like fucking psych wards and shit? Like, you know, there's just, you know, there's a lot of people doing crazy stuff out there. You know, it's nothing crazy. Anyway, we're gonna have a vec3 position, and then the classic UN32T pad that you need on the GPU. We need the vertex normal pad 1, and I think that should be it. We have the UVs. I think we need the UVs because that's what we sample with. I think that should be it. I don't think that we need the lightmap UVs on this because we map it later. We should map it later. Okay. The Tri GPU is literally just going to have a UVec3. We need the type for UVec3 because I didn't make it before now. So I have Roblox coder every 40 views. You deserve at least 150 viewers. Yeah, I mean, I think that the algorithm just isn't like the biggest fan of me. Ever since, I don't remember when, but like I remember when I started, like we would get like 50 views pretty regularly. But you know, it happens in waves. Like when I made the chess engine video and got like 20,000 views or whatever that was, like out of the blue or whatever, like that was like a kind of like a freak accident sort of thing. It kind of like works like that, you know. You don't really ever see the people who don't get views, you know what I mean? Like I get every Tokyo Spliff stream, you know, I get it in my feed immediately, you know. So that's like kind of what people's idea of it is, right? But the truth is there's like a billion guys like me or whatever that do this stuff as well, you know what I mean? So it's you just don't see them, you know. But I'm definitely not the only one. Also, I do 100% like understand that my content is way more like free, flowy, and less structured. I think a lot of people like prefer structure and something stimulating. My stream has never been very stimulating, you know. It's kind of just me just coding, just pure coding, you know, and figuring things out, and that's it, you know. It's not that's it. We'll just leave it a pointer. It's gonna be unsized. And Subway service at the bottom. Yeah. Yeah. So indices, and I think we want the tri-normal. I'm not really sure. And we want the mesh ID. Yeah. This is actually the mesh node ID. For reasons. Because mesh nodes can be duplicated. Okay. This is going to be really tough what I'm about to do, because we have to... Basically, every mesh has a certain amount of triangles, right? And when we send that to the GPU, we want to make a massive array of that because we want to have unsized arrays of all of it, you know? How long does it take to acquire this amount of knowledge? Yeah, about 2 years. I've been programming for a long time though. But the graphic stuff about 2 years, yeah. I feel like I'm way over my head all of a sudden with this. Do you think, Anna, like that it's worth doing it the way that I'm about to do it, and that which way would you do it? Would you just set an upper limit of triangles for your meshes, or would you... Oh, you're disoriented? Okay, don't worry about it. Don't worry about it. I'll figure it out. I will figure it out. And if I do it the bad way, then we will get through it. Okay, so we want the start vertex vertex count. Obviously, let's call it vertex offset. And then the try offset and try count in that array. And then we want the let's have this mesh node ID. Let's have the mesh ID. Let's have... What else is on this? Oh, right. Yeah, the model matrix and stuff like this. So, mat for global matrix and mat for inverse global matrix. And we want to pad this out. Yeah. So this is 4 up here. This is 4 down here. let's swap these two because this makes sense. There we go. Okay, and that's the mesh data done. I said this was going to be a lot of work. And you still get people, right there, you must be programming like, I have the field server program. Compared to Terry Davis before. I mean, I don't know. I don't really see like any problem with that. It's like, you know, it's like, you know, when I would go to these parties and, you know, my friend would be there and we would be drinking PBRs, you know, and these were like actor guys. These guys were actors, you know, and we just come from a screening of their movie or whatever, you know, and we were just, you know, sitting there and smoking and drinking and stuff. And, you know, people would come over and be like, dude, you were just like, who did he say? Bruce Willis. You were just like Bruce Willis in that, you know, like you had the same eyes and stuff like that, you know. And he would be like, thanks, man. You know, that's really, you know, wild. You'd say that about me, you know, but I really appreciate it, you know. And like, you know, it's like the same thing. So it's like a level of flattery. I mean, people don't have, you know, people who aren't actors, you know, don't know the world of acting, you know, even though the guy is really nothing like Bruce Willis, for sure. I mean, it was still like a massive compliment. Or I'm not sure, but isn't it like a bit faster? I don't use Unreal because the joy of programming isn't in engines, you know. You know, it's way easier to make things that are unique when you're not using other people's tools, you know what I mean? It's true in like any level of art, right? Like if you're, you know, you play your guitar, you know, you play your, you know, I'm not saying you have to make a guitar, right? But it's your guitar, you know, like you buy your special, like my 6-string, you know what I mean? It wasn't like I went out and I got, you know, whatever, the classic Elliott Smith Yamaha or whatever, you know. I found my own guitar because it enabled me to make what was mine, you know what I mean? So that's the way I view it. Like, everybody has their own tools. Everybody that has any fucking salt in the game, you know what I mean? Like, anyone who can say anything about art uses their own tools, you know. I don't know a single artist that is worth anything that uses just the, you know, the stock standard whatever, you know. You kind of have to pave your own way. You can go your own way. Go your own way. So BVH node GPU. We need inside of the BVH node the same thing that's within our BVH nodes. You can go your own way. Alright, peace out, freaky diddler. Yep, just add it. Just add it. Yep, just add it. Just add it. You just add it. You just add it. You just add it. What? You just add it. I'm not sure what we need in ABB GPU. Yeah, I'm just adding this right now. I'm just adding about 100 lines of code of just raw types that I'm about to send to the GPU. So that's what I'm just adding right now. I'm just adding it. You know? Now, what were you asking? Would you have a maximum amount of triangles or vertices per mesh that you would basically, so when you have an SSPO, would you just have like a define for that amount, or would you do what I'm doing right now, which is fucking completely insane, which is I'm going to unwrap all of the triangles and vertices and put them in one massive array so that it can be unsized, and then just remap all of the indices. Because I want to have I want to have meshes that can have, you do the second? Okay. We're gonna have fun. We're gonna have fun. This means that I have to loop over everything and remap everything. And this is so bad. Okay, so that's the BVH node. Setting a cap is improper. Well, I'm going to need a cap for the BVH nodes. So. Or wait, do I? Wait, do I? Wait, no, I don't. No, I don't. Oh, shit. Wow, that's awesome. Well, I don't need a cap for anything. Damn. That's crazy. That's crazy. You can go your own way. Go your own way. Anything could go a lonely day. You need to already have the spaces open. You build on the CPU, so shouldn't you need a cap? So you shouldn't need a cap? No. But for the okay, so for the triangles and the vertices, I need to have the triangles and the vertices on the GPU. So if I just had them on the mesh SSBO, then I would need a cap. You see what I'm saying? Because you can only have one unsized array per SSBO. So if I just had a mesh SSBO, you got triangle array, mesh array, Okay, that's what I have to do then. That's what I have to do. It's just a bit fucking annoying for me to have to do that. I'm sorry. It's annoying that the triangles have to have their indices all. Yeah, I mean that's what I'm doing right now. But yeah, it's kind of a lot of fucking a lot of shit, you know. The good thing is I think I can just do this for both. Yeah, I mean it's fine. I had a flat array on the CPU in my last engine, but it's not very convenient because my drawing still has the original indices, obviously. So my GPU data is going to have different indices than my CPU stuff, which is going to just cause problems. I already know it's going to cause fucking problems, you know what I mean? So it's just going to cause problems. My material GPU needs to have the handles now. I also have to do bindless for this, by the way. I also have to do bindless for this. So I may as well have all of the handles in here. Fuck, my fucking padding is all off here. Hold on. 4, 3. This still needs. You can go your own way. A triangle and index array. Yeah. It's just a lot to have to code all at once. Do you get what I'm saying? I have to create literally 6 SSBOs right now. Like it's just completely fucking ridiculous. Okay. I almost kind of want to just have the lightmap UVs on here. I don't know if that's stupid. Possible to master this magic? You just gotta give it time. Just give it time. Okay. I'll have to, yeah. Yeah, at this point, I mean, if I just do this on the GPU, I can basically, I mean, once I have all of this on the GPU, then I can, you know, do so much with it. So once I get this done, it's like, it's, a lot is opened up to me. So I think it needs to get done, you know. I think just for us being really simple here, I think all I'm gonna do is just start from 4, 5, 6. Just start 4, 5, 6. Not even worry about the binding locations. We're not gonna run out of binding locations yet. I'm just not gonna worry about the logic for it. You can use it for MDI. Yeah, apparently the culling is good with it. Um, the only problem is, you know, updating it. That's the problem. Is updating the arrays. It's kind of a pain in the fucking ass. Especially for me for this, for example, right? Like, it's complicated because of the lightmap UVs and the way it works out. It's complicated. Because basically, like, sometimes I need, for example, like if the asset appears twice and it is going into the lightmap, right? I don't obviously duplicate the vertices, but I have to store a second reference and stuff like that. It's fucking really global scene buffer. Yeah, probably. I don't know. I mean, I have instances. That's how I do my draw calls, right? But this is kind of, you know, a lot of maintenance if I do this. It's a lot of maintenance. Let's just do them in order. Okay, I'm trying to do this the fancy way, but now I'm remembering why I don't do things the fancy way. It's a quick buffer. I mean, at this point, I just should make a G buffer. I'm just joking. I think G buffers are just too slow for my computers. It's like the mesh data, which is big and slow to upload. I see. You can go your own way. Go your own way. You can do fun on a lonely day. Okay, here's what I'm gonna do. I'm gonna do something that's smart. For once, okay. In globals, we will have a flag bool uploaded. I kind of only wanted to upload this when necessary for now. Okay, I don't fucking care. We're gonna do it every time. What file do I put this in? Dynamic draws to edit a lot. Okay. In real time instead of during it. Okay. Let's see. Yeah, I don't know. None of this is really going to be used during runtime right now, so maybe later. Let's have it in a init, I guess. I don't like abusing this file too much, but fine. Let's actually start prefixing with GPU for this stuff. These also are going to have to live here, obviously. You can go your own way. Go your own way. Kill this SBO and well, do another whatever, so you don't need to redo everything. Yeah, that's true. That is true. But I am kind of already overwhelmed right now. I'm like painfully overwhelmed right now. It's kind of like fucking killing me, you know. I just don't know how to handle what we're doing right now. So okay, so we have to upload the scene data. Okay. Tricky. So which one do we want to start with first? I think the most important thing is the mesh stuff. Obviously. So we want to go per mesh node. Per mesh node. This mesh GPU is a per mesh node thing. So per mesh node, I go to the target mesh. No, per mesh I have to do it. Okay. I just kind of figured out how we're gonna do it. Yeah. It's hard to do. It's hard to do for sure. We want to go through meshes, and then for each mesh node that we find, cast fec, always with the fucking cast fec. Should do upload and remove individual entities, and then when you want to upload the full scene, you just loop every object. In my case, called upload a ray tracer. In my case, it's not. It's unfortunately not that. Obviously, because I have to remap the mesh nodes can reference the same mesh, so that's kind of difficult to do that. Right now I'm looping through every mesh, and then for each mesh node that references that mesh, I'm going to map them to the same place. Do you get what I'm saying? So I need to maintain kind of two lists, you know. Okay, so if the mn mesh equals the MID, then we upload it. Yeah, it's complicated because I have to unwrap the triangles and the points, right? So I have to keep an offset for it, and then have each mesh node reference the same offset. So that's what I have to do here. A lot of nesting. Holy fucking shit. Okay. We're gonna call a different function here. We can derive that information. It's fucking hair. Okay. We need to vector expand the vertices by the amount of vertices in here. And then we're going to get the tries, which is we're going to do it the exact same way. And then we just fill them up and add the offset to them. No, you don't want to. You want to do this over there. We need the offset before we expand. I don't even think we need the try offset, but this is obviously vertices. Okay. Sorry, I kind of have to stay locked in today. Or else I'm gonna just like not be able to get through it. Okay. So before we forget, the most important thing here, right, is that we're going into vertex. Let's call these this, and then this is going to be, this is obviously not vertex GPU, this is try GPU, and so for try GPU pointer T, TSI is correct, T, the mesh node ID will equal, fuck. Do we really need the mesh node ID or the mesh ID? Oh shit. I think I want the mesh ID rather than the mesh node ID. Yeah, I need the mesh ID. We can derive the mesh node ID when we traverse the BBH later. So the indices, the first index is obviously going to be M or MF indices 0, but we need to offset it by the vertex offset that we were talking about earlier. And this we do for each point. Also, for the normal, I think that we can just copy it normally. The material ID, is it necessary for the triangle to have it itself? Maybe. Let's just keep it here, just in case, because I do have it on the MF anyway. So let's just do it. Okay, so that's the triangle figured out. Now for the point, we want to get the vertex GPU V equals I. We're setting this up very cleanly here. The normal we should be able to copy straight from the point. The position we should be able to copy straight from the point. The UV we should copy straight from the point. Alright, I did a vec3 for the UVs when obviously it's a vec2. Okay. And this should unwrap everything and the tries and the vertices and all of that. So if we haven't unwrapped it yet and we find an instance of the mesh in a mesh node, that means that it's time to unwrap. So we'll call GPU unwrap mesh to buffers with the mesh and our vertices and our tries. Okay, otherwise, we want to well, how about this? Either way, we need to set this mesh to, or this mesh node to this specific thing, right? And so we have this thing called mesh data for the mesh nodes. And so we're going to index into it. I think it should be the same indexing as our current mesh nodes. So that's what I'm going to opt for here. So mesh data J. And we will fill in this mesh data for this mesh node, right? And so the vertex offset will be the vertex offset before we wrap. So let's have a 32T vertex offset, that is a rolling vertex offset, and a rolling face offset. And then before we unwrap, we will update it to vertex offset equals vertices dot count, and our face offset equals the tries dot count. And then we will have this as well for the vertex count and the vertex and the face count. We will have this afterwards. We will do the vertex count equals vertices dot count minus the vertex offset that we got before, and the face count tries count minus the face offset. Okay. Now the vertex offset will be the vertex offset, and we should just be filling in here for the rest of it. Yeah. I named it the wrong thing, I'm sorry. Oh, fuck off. Okay. Mesh node ID will be mn ID, and the mesh ID will be mid. The global matrix will be the mn global matrix, and we will do an M4 inverse on a float pointer to the mesh data J dot inverse global matrix using the mn global matrix. What is the problem? What? I mean, it's like what is the issue here? Oh, I'm sorry. I just had a fucking moment. I usually don't have my things like that, so it's confused me. And that should technically be it. That should technically be it for unwrapping all of it. We want to make sure that we're freeing all of this, obviously. So we'll just write all the frees here. We're going to free the mesh data. We will free the vertices.buffer. We will free the tries.buffer. And we want to wrap this in if statements, of course, just to be safe. Okay, so going down the list here, we have dealt with the vertices, the tries, and the mesh data so far. Now we just have to write the upload for it. Do I have the boilerplate for that I can just grab? I have it over here. Okay. Once again, this is Jarvis. This is Jarvis's work here. So say thank you to Jarvis. Thank you, Jarvis. Okay. So we're gonna bind the vertex SSBO, and it will be the size of vertex GPU times maybe we want to maintain these buffers and not just free them. Copies on the CPU side of them. If we want to do that, then we can. It's not hard. Let's do it. What are they called? What did I call this? Call this mesh data. What did I call this? Okay. Sorry, I'm not talking a lot. I'm kind of very overwhelmed with this today. It's a lot. It's very, very difficult. So I'm just trying to think through it so I don't fuck it up, because if I fuck it up, then it's gonna be really bad. And I'm not gonna really know how to fix it. So I have to kind of lock in. So I'm sorry, I'm not really talking through what I'm doing. So you switched to Windows 10? I have been on Windows 10 because the drivers are not as bad for my computer. My computer is an old computer, an old laptop, and the Linux drivers just, for NVIDIA specifically, just aren't nice to older computers. So that's why. It's not really out of choice, really, but this is global.mesh nodes, right? Okay. So now it's just the BVHs. It is just the BVHs left. Which is arguably going to be the hardest part, I think. Because we have to do all of this. And it's all nested. Okay, let's do it. Let us calc this to... Wait, no, this is per... Oh, fuck. Oh, I need another one. Oh, no, I don't. I just need this node count on the mesh data itself. And this is another one. Fuck. Yeah, this goes over here for sure. Node count. Sorry, today's kind of like a bad introduction to the stream. It's a very kind of difficult day. Were you having a beard? How long have I... You just didn't notice, didn't remember. I think when you watched the stream, I probably just didn't have a face cam, maybe. I've always had it. Been a long time since I didn't have a beard. Maybe it wasn't this long, but it's been probably like 2-3 years since I haven't had a beard. This is hard. We need a node count and a node offset because they're all going to be flanned out. Oh, this is difficult now. So when we're unwrapping the meshed buffers, we need to also do the nodes. PVH node GPU. And we'll pass that in here. And we'll have a moving offset as well for this. Oh, by the way, I didn't do... Yeah, this should be like this, obviously. Don't want to get that messed up. Okay, so what we're doing here is I want to have an unlimited amount of PVH nodes on the GPU, and so what I have to do is oh, by the way, it's very good to see you. I'm sorry, it's been a while. So what I need to do is I'm unwrapping them into one giant buffer of PVH nodes, and so I need to store on the mesh data where they live, right? And so that's what we have to do here. So similarly to this stuff, we need to take in that nodes, and we want to where is your nodes? PVH indices, where are your nodes? Leaf indices. Nodes, there it is. PVH node. Okay, I just looked at that and I kind of got tilted for a second. Holy shit. How left, right, parent index, first index count? Is that really all I need? I temporarily clicked on your stream like a week ago. Cube with pretty nice physics. I could let all the kind of weird in some cases. Is this game engine that one? It is. It is. Although kind of weird in some cases. What do you mean by that? Kind of weird. Shit. Let me map this to the code. Where in the acceleration bilinear, where is the actual ray traverse? Yeah, so do I actually ray traverse node count SD BVH indices, scene data BVH indices? Oh shit. Mesh indices. Oh shit. The lighting was weird on the cube. Yeah, it was kind of, I was working on some stuff. Shit. I'm trying to figure out a way so that I don't have to get another buffer for the indices. The node has a count and it goes into the indices. Fuck. Do I need another SSBO? Just for the indices? And then shift them... Oh. I think I might, you know? I think I might. Ah, shit. I don't think I use the leaf indices. I think that it's these indices. I wonder if these are necessary. If I built my BVH properly, they shouldn't be necessary, right? Right? No, yeah, they do map back out. They do map back out. Oh, shit. Yeah. Yeah, I need another BVH, I think. Fuck. That sucks. Yeah, I can't do it without another one. Yeah, I can't. I can't do it without another one because the way a BVH works out is that they aren't contiguous in space. The start and offset are not in order, obviously, for all the nodes. Shit. Unless, hold on a second, hold on. Let me think about something here. What if I sort them? What if I sort the nodes in that order? I might have to do that, you know. I think that that's possible. Node count and node first index. And then I sort them in that order. I think so. You know. I'd have to make sure that there's no duplicates or anything like this. But I think so. To make them in that order. You know, I think it's possible. I think it's possible. You go BVH indices. Is it just nodes.count? You want to cast vec for them. We're gonna call them BVH nodes, okay? Actually, you don't want the one at this location. You want to take instead the M BVH indices with that. Let me think. No, but then the start and the count are gonna be in the wrong place. Fuck. God, this is actually so problematic. That is actually insane. Hey, what's up, Enigma? What's up? Oh my god, yeah, I'm struggling with a really complex issue right now. Basically I have this tree acceleration structure that has this array that indexes into it, and that's how we traverse it. But I'm trying to get rid of that structure that sits in the middle, and I'm trying to sort the array so that we don't have that structure anymore, basically. So I'm just trying to think about it through my head. It's been alright. Is stuff going well with you? Can I do this? Can I even do this? It's 0 and then fuck. This is gonna be so complicated if I don't. Oh my god. Oh, fuck. Oh, no. Oh, no. Oh, no, 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 no. It's only for the children. It's only for the children. It's only for the children. No, it's necessary. 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 It is necessary. It's necessary. It's necessary. Okay, so we have to have another one. We have to have another one. We have to have another one. Fuck. Do we have to have 2 more? 1 for each BVH? One for each BVH. For the children indices. Yeah. See, the things are doing great. Yeah, it's complicated what we have to do here. I'm sorry, but it's very complicated. We need indices. We need the indices to be in a separate SSBO. For the bottommost children of the tree, they have an array that is sorted that tells them what they're pointing to. However, those indices might be duplicated, and so that array needs its own SSBO because it can be unsized. Or can it be? I think, you know, I think it has been going good. Oh, that sucks. Is it 2 more days free? That's what it's all about. It's about the program, the programming. The BVH indices is ooh. I just had an idea. What if we sort the triangles based on the BVH? Literally sort the triangles based on the BVH. And then literally sort the mesh nodes based on the scene BVH. Right? That way we don't have to have this because they're already sorted. Is it possible? No, it's necessary. It's necessary. You know that scene? No, it's necessary. I think it's necessary. Hold on. I think we can sort the triangles. All we have to do is BVH indices this. BVH indices is always going to be the exact size. Mesh try BVH. Where is this function? Mesh try BVH. It's always the exact size of the tries, right? Malloc to mesh size indices. Free indices. BVH indices. Mesh tries count. Yeah. It's always sorted. So we sort them like this. And then our nodes always point into the correct place automatically. In fact, I should already be doing this on the CPU. Sorting them based on the BVH. Okay, but let's not get too ahead of ourselves here. Okay. Let's call this node, and we will get BVH node GPU pointer n equals at n's I, and then we just copy over what we have already here. It's kind of a pain in the ass, I'm not gonna lie. Also, parent can be -1, so these should be int 32Ts. So this is my fault, as is literally everything. That's alright though. So the first index and the count are obviously, so the index is this, so int 32T. I'm glad that I thought about that so much, because that's going to really help us out today. If I had just made those other two SSBOs, I mean, I would have really been in trouble, I think. Can count be a -1? I think count and first index can be -1, and I want to avoid any weirdness with this. So I know we like unsigning everything typically, but that is this is an AABB GPU with the padding, We're being very careful to not fuck things up right now, because if we fuck something up here, it is going to be royally fucked up. Okay, it's gonna be royally fucked up if we fuck this up. I mean, like, seriously. Sorry, I'm a bit distracted today because of the kind of just about the... Can you fuck off? What the fuck are you doing? I'm a bit distracted today because of how much code we have to write. It's a lot of... Or memcopy, because they're two completely different structs. Because this has padding for the GPU. Look at this. Padding. It's all... We are prepping all of our data from the CPU to be sent into SSBOs for the GPU. This tree be utilized for? This tree is something from a long time ago. So this is just a tree that goes over all of the triangles in the engine. Every single mesh has a tree of all of the triangles to make it faster to find which triangle we're hitting, right? So when we shoot out a ray of light, we didn't know what triangle we're gonna hit, right? And it's very slow to test thousands, right? So we need to move this to the GPU because we're moving these lighting calculations to the GPU now. So whatever you picked in is always wrong. Yeah, you need to do the padding yourself, because everything has to be padded. Everything has to be aligned properly. So that's the goal. Okay, there was something else that I did here. Right, the node count. Yeah, make sure to do this shit, because I almost forgot about this. Node offset, node count. Now our triangles are going to be in different order on the GPU than on the CPU. Node. We have to remember that our triangles are in a different order on the GPU. May cause us very, very large amounts of problems later. Okay. This may cause us a lot of problems later. In fact, I'm almost like considering right now just replacing it. Like, it's hard. I'm just trying to think ahead, like, I'm not sure. I'm not sure what's gonna happen. Because these are going to be used for ray calculations, but later if I need to, about the lightmap UVs, if we need to line them up to the same triangles, I don't know what's going to happen. Let's just leave the note there, and let's just face that when we get to it. I don't know. Yeah, I knew today is going to be a hard day, so this is just the way it is right now. Cross-platform fun, yeah. Yep. Okay. Okay, so we vector expand it, and we get all of the nodes into the buffer, and then we upload them like this. BVH node GPU, not BVH GPU, BVH node GPU to the nodes that count, nodes that buffer. Okay, we have one more left. We have one more left, and it's just the scene BVH. The tricky thing, and the funny thing about the scene BVH, though, is that we have to make it do the same thing, the same thing as the fucking mesh BVH that we just did, and we have to pre-sort these as well. This is certainly going to cause some problems. Double note. Fuck, you're shitting me right now. No way, we have to order our meshes differently on the fucking... we have to order our meshes differently. No, but then the IDs are wrong. Are they wrong? Oh, fucking shit. Reorder draw command / instances. No, that's not what we're doing. That's completely trivial. That's not. I'm reordering the meshes themselves. This isn't draw commands. This is us making an offline lightmap baker on the GPU, meaning that these 6 SSBOs are all of our CPU side data on the GPU, right? Okay. The problem with this is that our BVHs are sorted in a manner where they have an array that has the indices at the bottom. The indices that map into the meshes. and map into the tries. However, I don't want to maintain another 2 more SSBOs for those. I don't want to. Hold on a second. Our mesh try BVH has the same indices as the tries, so we don't have to pre-order them. We can redirect later. Holy fucking shit. That might just be the smartest thing I've come up with, like, in months. Holy shit. On the triangle struct, you put in here BVH index, and instead of going to that triangle, it will redirect to the other triangle. Holy fucking shit. What the fuck? And you have it on the mesh as well. It redirects to the other one. So when you use the BVH to go to this mesh, it instead goes to a totally different mesh to maintain the ordering, so that we don't have to maintain another array. And so instead of reordering them and fucking everything up, we instead just have an index here which does that. Are you fucking hearing what I'm putting down right now? I mean, like, what? And then you have this in mesh data too. And instead you have this to the scene data BVH indices. If you go down to Hammond, you'll never come back. In my opinion, you're on the wrong track. We'll always love you, but... Okay, lock in. Lock the fuck in. Okay, so everything that we just did for this BVH node thing, we have to also do for the scene BVH nodes. Right. Hopefully we can just copy this pretty much. If you go down to Hammond, you'll never come back. In my opinion, you're on the wrong track. Holy shit, I can't wait till this is over. Holy fucking shit. I cannot wait until we finish this. I'm like I'm gonna be so fucking happy when we no longer have to do this shit. Oh my god. This is torturous. This is like fucking crazy. Okay. And if you go down to him, you'll never come back. Down. In my opinion, you're on the wrong track. Ah, fucking Christ, what am I fucking calling this shit? We called that nodes. We're just gonna call it S nodes. In my opinion, you're on the wrong track. We'll always love you, but that's not the point. Okay. Alright, that should be it. 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 And let's put it with the other stuff so that it's all nice and neat. Not that stuff. Let's just put it over here so it's all nice and neat. And let's upload it to the GPU. We want to go to globals.scenedata.bvhnodes.count, and this is going to be the S nodes. Holy fucking shit, we're done. Oh my god, I never want to touch this shit again, but I'm gonna have to. Oh my god, oh my god, oh my god, we're done. The funny thing is, all of this, all of the shit that we just did for the past fucking 2 hours is just the upload to the GPU. So, we haven't even done the fun part, which is the actual code, so. Fun. Good stuff, guys. Good stuff. Okay. Okay, let's just double check ourselves that we did everything correctly. I think we did, but... I think we did. It looks good. It looks solid. That's okay. That's okay. Listen, I'm only here for... because if I was to do this alone, I think I would like mentally just have a breakdown, to be honest. I would just actually fucking just lose it. I would just fucking lose it. Like, seriously. This shit is crazy. Okay. We'll always love you. Okay, we haven't actually written any of the actual code yet. So let's write the actual code. So earlier we made these two shaders, which are the G buffer for not lighting, but the light map, which is kind of fucking a little bit of a funny thing, isn't it? So to do this, okay, so what we're doing here, if I can explain it properly, we have a triangle and we want to put it on the light map. And so we tell the GPU, hey, we have a triangle, we want to put it on the light map, and we give it the UVs and it puts it on the light map. Okay, that's all it's doing. The tricky fucking thing that we have to do, though, is do that. We need to give each triangle its light map UVs. We need to give each triangle its lightmap UVs beforehand. Okay, how do we fucking do that? Okay, when we assign UVs, do we actually UVI tries that count, MF tries I? We have the try here. Why don't we literally just put it on the MF? We have the UVs here, we put them here. On the wrong track. We had this complicated thing that we did here, didn't we? We did a complicated thing here with this. When we emitted the triangles, we did this. Lightmap data.uvs. And we put it in there. Why don't we just put it on the MF? Just do it automatically. Why don't we just do it automatically from here? UV's I, UV's J. Right, because I duplicate them later for the instances and shit. Let me refamiliarize myself with the geometry shader and the way that I did this. UV's face start index plus I. I think I need to duplicate the logic. I think I need to have the same logic. God, this is gonna be hard actually. This is gonna be really hard. Oh my god. Because this has our UVs and we need to fucking... fuck. Oh, this is really tough. Increase/decrease vertices. Yeah, basically increase, decrease vertices. So basically, right, to explain what's happening, right, is that we have some vertices for this model, right? that we want to draw to the screen, but we want to light map it first, right? And then it just so happens that we have two of them, that we have basically one instance of the mesh and another instance of the mesh. Well, we only want to unwrap the UVs once, right? And then reuse the UVs for the other mesh. However, we don't want to duplicate the vertices, right? We want to keep the same vertices, but have two different sets of UVs. However, that's like really fucking difficult because of the way vertex data works, right? So we use a geometry shader in between to assign the UVs when we are emitting triangles. But yes, it's kind of a pain in the ass. The tricky thing is, I'm moving my lightmap baking to the GPU, right? And so I need to have those UVs when I rasterize the triangles onto the lightmap. Basically, the lightmap is going to become a frame buffer that we're rasterizing on top of. The problem is that I did this in a way where we have this convoluted geometry shader UV thing, and now I have to figure out how to do this. Because this is how we rasterize onto the light map itself. So here, I think we need to duplicate the vertices. I think we duplicate the vertices here. I think talking this out really helped me, but I think we duplicate the vertices just for this pass. We have a specific light map vertices that we do, and we just do this pass just to rasterize it onto the thing. And I think that's what I'm gonna do. And it'll have its own VAO and VBO. And it just goes through this once. Okay. This is very, very complicated. Where are my other vertex stuffs? My other vertex stuff. Okay. Okay, pause, normal. We also want, the thing is, for this, right, we also want out material mesh try ID, right? So we need to give it the mesh ID that it's a part of. So I think for this purpose, since we need it to be per vertex, we give it that, right? Right? Yeah. Okay, so I think we only need the mesh ID and the mesh and the try ID. I mean, you could even send those as uniforms, actually. Obviously, the try ID you wouldn't send as a uniform, but you could just use GL primitive ID for this. Okay, so you don't need that. You can get that. And then when you have the mesh ID as a uniform, let's just not forget about this. And then we'll just use the mesh ID to index into the the SSBO and then get the material out of it, and then we'll just write the material, the mesh and the try ID just to one place. Yeah. Okay. So basically what I'm doing here is we're writing to 3 different buffers in a G buffer. The first one's going to have the position of our triangles, the second one's going to have the normal of our triangles, and the third one is going to have the IDs for the rest of the calculations, because we technically will need this to exist, I think. Anyway, so let's make the let's make it. All right, so we need an FBO, we need a VAO and a VAO. It's like we're rendering a thing within a thing, I guess. In my opinion, I see why people make their light mappers completely separate programs now. After doing this, I completely understand why. It makes a lot of sense why. It's a lot of, I guess, added code overhead, but like the mental kind of separation makes a lot of sense, because this stuff is it's basically like a totally separate rendering pipeline that you have to set up if you want to do this on the GPU. It's kind of a pain in the ass, to be honest. Okay, so we want to set up this frame buffer. So let's go to where our frame buffers are. And we need 3 attachments. So we're going to have 3 different textures. In my opinion, you're on the wrong track. That's not the point. God, this is such a mess. Like, this should be up with the FBO up here. The depth texture should be over here. This is such a mess, the way I did this. This is just, oh, I was probably going to make this, calling this lightmap texture is bad. Lightmap position texture, and we'll have lightmap normal texture and lightmap ID texture. If you go down to Hammond, you'll never come back. On the wrong track. Okay. Yeah, I'm glad that I didn't call it light map text, because then we would have had a problem. So I think that we're gonna do it with, why would it be vec4 though? Maybe there's a purpose for it in terms of the GPU stuff, in terms of compute, maybe. I think that we'll stick with it. On the wrong track. And so we'll just do 32F. We want to standardize the size of our light map texture for this purpose. For now, let's actually just like hard code an upper limit for now, just so that we can get our heads around this. Why is this broken? Can you fuck off? Why are you broken? Oh my god, sorry. I just restarted my LSP and this is still fucking stuck on the fucking screen. Oh my god, you're really gonna make me restart right now. Fuck you. God, like, bro. It's so annoying. I don't know why that happened. Okay. Okay, we need to make that a constant for now. We're just gonna make it, we're gonna make it 2048. If our UVs are correct, we should never be going over 2048. Earlier today, I did 2048 with Sponza, so that's exactly what I'm with the fish shell. Yeah, I agree. Fish shell is pretty shit. I had my own problems with some of the shit that I had to do with it, so I get it. We can make that a not constant later, but for now, we're just gonna have it a constant. Because I need this to be set to something. I think everything will just be GL linear. You're on the wrong track. This is going to be norm texture, and then this one's going to be the funky one. The ID texture is going to be the funky one, because this is not RGBA 32F. This one's going to be RGB. Can I do 8U 16UI or 32 UI? Let's just do 32 UI so that we don't have to worry about the. Let's just start with 32 UI, because then we get to unsigned int. Unsigned int should be the 32-bit, right? And we want to be GL nearest. I'm pretty sure. God, what the fuck am I doing right now? Like, what the fuck is this? I'm sorry. I just like. Yeah, this is fucking crazy. Okay. What the fuck is this? Okay. That's fine. Apparently something with if. Yeah, I had some bullshit with that. They have like the wrong symbols. They just don't accept some symbols or some shit. Yeah, I don't know why. They have a weird parsing thing. Literally, I set up fish once, and my entire fucking computer didn't work. Because it's fucking bullshit. In my opinion, you're on the wrong track. Alright, let's make the FBO. In my opinion, you're on the wrong track. Dun, dun. Can I go attachment 2? I think I can. There's apparently like a limit to these things. But I think since G buffers are a thing, it has to be possible for you to do 3, right? For sure. On like all hardware, right? Has to be. In my opinion, you're a freaking dumbass. No, it's stupid. Their shit is stupid. Their shit is dumb as fuck. Trust me. Oh, that's a rip. No, but their stuff is stupid. Their stuff is definitely stupid. $100%. I have to set up the shader. I made it a GLU instead of a shader program. In my opinion, you're on the wrong track. That's not the point. Why didn't it print the error echo now? Listen. It's stupid. Trust me on this one. Their shit is stupid. Their shit is so stupid. I'll never use fish shell again after that. That was disgusting what I experienced. Okay. Is it okay for me to upload material data here? It has to be, right? Let's go into the init folder and let's GPU upload scene data. I think I already put it in the header. That they're trying to support without actually, that's my problem with it. I don't know much about shells and scripting and all that, but the fact that they just don't allow bash syntax and they have like their own whole fucking thing going on is so stupid. Like, why? Like, for what purpose? It makes no fucking sense. It's so dumb. It's like, why do I have to learn your fucking whole, like, dude, I just want a shell that works. It's so weird. It's like saying, hey, I want you to read my novel. And you just, like, open it up, it's just in a different fucking language. Like, bro. Like, we're friends. You know that I speak English. It's not identical to bash. Instead of a mode and hence enabling actual progression? Yeah, exactly. So when I installed fish shell and nothing fucking worked anymore, how is that my fault? That's not my fault. That's their fault. Anyway, we have to rasterize this shit onto the textures. I have to figure out how to do that though. I have to fill. When I bake my lightmap, I do init lightmap data, and then I go over all the mesh nodes, and if it's not a static mesh, then I build UV islands. And then I init UV islands. And then basically you're just gonna replace this with we're just gonna for loop again over it. And then rasterize them. I think I'm just gonna GL draw arrays because it's just simple. And the UVs are different per try. Uh-oh. I just started biting my nail off, and then it just got to a point where I'm just at a bad point with it. So I gotta stop. I gotta not do that. Uh-oh. Yeah, that's a bad one. I kind of want another coffee. I'm kind of feeling tired. Every variable is array. Everything is a keyword. Comes with that baseline. Yeah, I never got that deep into it. Not gonna lie. I just saw all of the errors that I had in my fucking bash RC or whatever, and then I was like, okay, never mind. I'd rather not have a shell at all. Fuck that shit. That shit is like having a job, dude. Like, dude, just let me use my computer. Like, what? Fuck. Dude, this nail of mine, not going good, not going good. Okay. Oh, it's getting in my way now. Why is LMUV Vec 3? Who wrote that code, huh? Your network is dying. Oh no. Okay, this is a tricky part. I need to figure out how to get to the LMUVs. I need to figure out how to get to those. I don't really remember how. It's whatever the fuck this shit is. It's MNUV map and then just do this. I am too lazy to really remember how to do that right now. I'm just gonna fucking copy paste the code and try and figure out how to get to it. MNUV map that UV IDX equals I. Okay, but where does that go into? What am I iterating there? The UV map goes into the UV islands, and also it's so complicated the way I did that. Holy shit. The UV map, UV IDX, goes into the UVI's tries count, but the UV map island is it indexed by triangle? Has to be. Apparently YouTube thought it was a good idea to make the stream chat a whole contained page that connects to their domain, because just now I'll blame that we cannot connect. Here's what we can do. Yeah, that's the classic. I don't know why they do that, actually. I don't know why. Oh my god, this is so painful. Holy fucking shit. That is some fucking code right there, guys. Wow. Wowzers. Crazy. I'm being brave with this nail right now. Okay. Oh my god, thank god. Thank god it's over. Okay. Close call. Close call. Could have been a short stream today. Okay. Now we just actually GL draw arrays this. Weird as that sounds. We just GL draw arrays this. Let us remember how to draw to the screen real quick with something like this. Let us just, you know, copy the classic stuff. I don't think we obviously need depth testing, but you know. Every error gets into the log. Turn off GL depth testing. We want to. Sure, we can do that. We can do that. Uniform one eye. Okay, so if I send in the mesh ID, that should map into the SSBO, so we don't even have to send as a const pointer if I am not doing any changes to it. I suppose so. I don't typically do it very often, but I suppose so. Yeah, that nail really cut close to the skin. I hope this is fine. It's all right. I love you, nail. That's all right. Don't worry about it. I think that I can. Since we have all that stuff, we shouldn't actually need to do it. We shouldn't even need this. Ow. I think my nail is mad at me after I cut it. I knew that nail was gonna give me some trouble. Okay. It's always these ones. It's always this finger that you gotta worry about, bro. Okay, moving on here. We need to move all the SSBO shit into here. So let's figure out how to do this. I think I really need the types. But I also need the fucking numbers, right? Let's see this. Let's see Paul Allen's card. Dude, that shit always gets stuck in my fucking head. Okay, we don't need everything here. All we need is the mesh one. So let's just do this. So mesh data. And this one is in my opinion, you're on the wrong track. Wait, hold on a second. This is mesh node. Oh yeah. Because of the transforms. Duh. Because of the transforms. Duh. So then, oh, I already am going. So just go mesh node ID. Today is going to be tough. Fuck you. Just fuck you. Dude, today's going to be a long day if I don't figure this out. The most annoying thing with fish is their decision to offset the base array index. What does that mean? Oh, I never did the matrices. If you go down to Hammond, you'll never come back. In my opinion, you're on the run. Oh, really? It's one? That is the stupidest thing ever. That is the stupidest, dumbest fucking thing ever. In my opinion, you're... Alright, I never did the matrices, so we have to do that real quick. Oh no, I did do it. Am I okay? I don't think I'm okay. I think I'm not so good right now. Okay, we have to make the VBO. We never made the VBO and the VAO. If you go down to Hammond, you'll never come back. Yeah, I need a coffee. I need a coffee. I do need a coffee. Can someone make me a coffee? I don't want to do a coffee right now. In my opinion, on the wrong track. Let's count 6, 8. Real quick one there. 6, 8. 0, 3, 1, 3, 2, 4, 2, 2. On the wrong track. How they implemented their syntax. There's a simple way while implementing non-simple things. Yeah, I'm just kind of an asshole who doesn't like different things. Just me personally, speaking. So whenever somebody does something differently, I'm just like, fuck that. Seriously? Material ID. Material ID. Luckily, I think I have that on actually, the triangles. So I can just put that in, actually in vertex, in the vertex layout, because otherwise I don't have the ability to do that unless I want to iterate the submeshes, which I don't really care to do. And then use a instead of making a monster. That's a good way of putting it. That is a good way of putting it. I think you can do try ID equals GL primitive ID. I think the material ID we're gonna have to actually work for. We can either put it in the vertex layout, or we can go for each submesh. Go through each submesh. Going through each submesh would be the cheapest way, and also the most surefire way. I don't really think, I don't even know if when we parse GLTF, if we give tries the material. We do. It's kind of lazy to do it that way, but it's kind of lazy if we do it that way. Basically, how we would do this instead is we would loop through, we would nest once more, and we would go as submeshes, and we would get submesh sems equals cast vec once again with m submeshes, I hate it because it's different, but I just don't get some of their city reasoning. Somehow different than a equals 0. Yeah, I mean, that's what I got from it as well. Which is why I don't use it. Oh wait, submeshes have indices and not triangles. Hold on a second. What? First index equals tries count. SM count. Sum count plus equals 3. Wait, have I been doing this wrong the whole time? Oh no, I do it here. Start index equals m and offset. Wait, but then where do I draw from? Oh, I do it here. Oh, I do it here. Okay, so this index count is divided by 3 since we work in triangles. Oh my god, this is complicated now. Oh my god. How do I do it over there, though? I don't. I just unwrap them like this in order. And then the submeshes just count. Fuck. Yeah, I guess. I mean, I don't really, care what reasoning they have for it. I just think it's stupid. But maybe that's just me being dumb. This is so complicated. Okay, here's what I'm going to do. I'm just going to leave a note here that we're postponing this till later. Because this is one of those things where if I make a mistake there and I make a bug there in that complicated indexing, it's just not worth the time right now. Like, there's so many more complicated things that I have to do. So let's just leave a note here. Meshes. This does mean that we have to edit the locations though. It sucks making it a per vertex thing, I know, because it shouldn't be, and it bothers me, but I can't do it the other way right now. I'm like gonna lose my mind doing it. Alright, peace out, Enigma. I hope that you have a good day, and don't get too bogged down by the stupidities of other programmers. You know? Your Wi-Fi is dropping. Yeah, well, I hope that good luck, and don't work yourself too hard on your days off. I think we're ready to draw. I think I'm ready to draw. Holy shit, we're actually about to fucking GL draw raise this shit. Oh my god, that's crazy. That's fucking crazy. We have to GL buffer data. We could technically just do one draw call for the whole thing, but really, like, don't do that. Just do buffer data. I'm about to make it so fucking complicated for no reason. But it has its own problem. It's certainly better than Bash, logically. Yeah, perhaps so. I don't really know much about either beyond the, classic stuff. And I will need the good luck. I will need it very much. This is like probably the craziest thing I've ever written, to be honest. How do you do this again? It's a GL array buffer, right? Yeah. Okay. LMV. Really, isn't this vertex count, not prim count? I don't really remember. I think it is, right? I'm pretty sure. I always forget, and then I do it one or the other way. I think it is this. Okay, I want to try to render this to the screen, just to see what it is, what it's happening. It's I don't know. Oh yeah, I never set this up, huh? Alright, I made this a material ID. In my opinion, you're on the wrong track. I'm worried about material ID not being unsigned. Worried about it being -1 at some point if we don't get an ID. Right now I'm not going to worry about it. We called it material mesh ID, so we're just going to do material I want to try to draw this to the screen. I don't know what it's going to look like. If it's just going to be the position that comes as color. I just want to see what happens. I'd only be interested to just like output the vertex colors as well, but I have no clue what's going to happen. So I say we just bake it and then draw it to the screen rather than to the lightmap FPO, just to see, and then let's just like not do anything else and not clear or anything. Or obviously we have to have a while loop here. Let's just not render anything else. I don't think that we swap either. Alright, this is going to take a while to compile. Let's try not a stupidly complicated model. Let's do RTGI demo scene. So RTGI demo scene. I don't see anything. Instead of world pause, let's try outputting just one or a color. Nothing. Let me try clear coloring it to 1 just to see if we can get something on the screen. Okay, now I'm kind of getting worried. If I get rid of this, we should just see white on the screen. White on the screen, right? Like, maybe I have to call the swap. Oh my god, sorry. Sorry about that. sorry, Wylan. Okay, I don't see anything though. Fuck. The problem is I don't even know if I'm supposed to see anything. But I'm assuming that I am supposed to see something. If I write these to 1s, probably supposed to see something. Fuck. Fuck. It's like, how am I supposed to even know? Like, I'm gonna guess that this is, I need to see let's just go and see the m tries dot count and the fucking, what do we even need to see here? Like, what do we even, how do I even debug this? What I just wrote. Basically what we're supposed to see is we're supposed to see the light map on the screen. Or, well, not the light map, but the rasterized positions of everything that's on the light map. Drawing 40 to 12. So those are all the triangle counts. So it is drawing them. How about this? How about this? How about this? Let us... Let's try something different here. Let's try, instead of... Let's just try putting the lightmap UVs into here. Let's try that. We may have a problem. I wonder if the frame buffer is broken or something. Also, we're using the default frame buffer, so there's also that we have to worry about. So let's just try using the default frame buffer properly. This is one attachment, because it may be like silently throwing an error. No. Oh shit. Shit. No, I don't know. Try not GL disabling GL depth test. Are able to... Oh, that's a good idea. That's a good idea. I could render dock it. In this case, yeah, that makes sense. That makes sense. I could do that. Yeah, I should render dock it. I don't have render dock on this computer yet, but I can get it real quick. I should probably do that. I just want to make sure real quick that there's nothing stupid that I'm missing. I could also try just hard coding the LM UVs really quick to something stupid. Like if I just unwrap this really quick just for the stupid purpose of debugging. Oh fuck. Yeah, this is kind of tedious, yeah, but just for the I just made that a 1 when I should have made it a 0, I know. The purpose here is that I can hard code the UVs to like 1 like 2 1 1. I'm probably off with my stride somewhere or something like this. Just try something like that. No, nothing. Yeah, I should probably render dock it. Obviously, the weird thing though is that this one clear color, when I clear colored it to red, it was flashing, which is weird because we only call this function once. I mean, I guess the swap, but weird. I definitely have something. I'm pretty sure it's with the stride. I'm pretty sure it has something to do with the stride. Let's just see where I did the stride, and let's see if I did something fucked up here. I did a trib eye pointer here, and I did size of float times 8 plus size of int, which should be correct. All of this looks correct. All right, I think it's time to render doc it. I'm sure that it's something. I'm not even using the SSBOs though. That's the thing. If I was using the SSBOs, then let's try just the first one or something like this. Just the first mesh node. Just want to make sure that I'm not drawing over it. No. God, it could be something that I'm just like. I could also try not going to the default FBO as well, and then just rendering it to a texture and then draw it as well. I could do that as well. That is something I could try. Let me try GL disable GL coal face as well. I don't think that is it though. Do I initialize the shader? Oh, I don't initialize the shader. Okay, okay. That was a close one. That was a close one. Okay, I could have gotten stuck there for way longer. Yeah, I just forgot to initialize the shader. GL primitive ID is not accessible in this profile. Oh, really? Is it only in frag shader? Oh, what's up, Anna? GL primitive ID. GL primitive ID in. Okay, but I think that's has to be in the fragment shader, so I don't like doing things in the fragment shader that you could just do in the vertex shader, but I think that you're supposed to do GL primitive ID in the fragment shader, so let's not even worry about that yet. While you were gone, we did all the SSBO flattening and shit. We had to do some cursed stuff. Okay. That's exactly what we wanted. That is exactly what we wanted. How painful is it going to be for me to put this back? Put that shit back where it came from, or so help me? So help me. Okay, thank God we can put this back. What we just saw there, that white flashing triangle, is what we want to see. That is what we want to see. Can I get rid of the swap? Now let's actually try drawing the shit. This try ID is obviously going to be GL primitive ID. It might be GL primitive ID in, I'm not really sure. Anyway, let's try and see what we can see here. I hope that everything's all right though. Okay, let's see. Okay, we don't see anything. We don't see anything. Okay, let's try with the swap. I think you have to have the swap or some shit. Is that it? Let me try something. I think that we're still only rendering one. Oh no, we're rendering. No, yeah, we're not rendering everything. That was the arch down there. That was your arch, Anna. At the bottom of the screen. Okay. And that is the positions of all of the things on the light map. That's our light map. Rasterized on the screen. So yeah, that's fun. Probably want to have disabled depth tests too. What's your arch? Your arch is from your model, from your asset. That was your first mesh node, was one called arch. How do I code for so long without using a debugger? I debug it myself. There's really no point in using a debugger for anything that I've done today. Nothing would have helped me with a debugger. Okay. I think that's correct. Brain debugging, yeah. I think that's correct. I mean, I have no way of knowing if it's correct. It looks like laid out like a light map, I suppose. Oh, something that we can check with it to just, this will verify if it's correct. If we set the padding of our light map like really high, then we should physically see the padding between the regions. That's something that we can do to check before we commit to doing the rest of this stuff that we have to do. Where the fuck is this? Holy shit, there's a lot in this file. Oh my god. Okay, so if I set this to like 24, we should see a lot more room on it. A lot more black space. There we go. See, a lot more black space with 24 padding, 24 padding in UVs between everything. So there we go. We have laid out our light map in an FBO in 2D by rasterizing by literally rendering the meshes onto it, which is kind of fucking crazy to think that you can do that. That's like fucking mind-blowing, to be honest, that this is how we're doing it. So now what we do is we we iterate over each texel in a compute shader. So that's what we have to do next. Okay. Hopefully this GL primitive ID thing works. Like, no clue if it's gonna work. So I'm just gonna assume that it does work, and we'll just move on. Okay, so once we draw everything to the screen, now we have to dispatch our compute shaders. I thought that was the default. I guess it is the default, I guess, but like I did it on the CPU. Remember, like my old game engine? My old engine was CPU light mapping, you know? And so when I made this engine, I naturally did it that way. But then I looked it up and it kind of blew my mind that people did it this way. Because I just had a 2D texture with the UVs, like all of like the Rex and the blocks and the this and the that, you know, to do the UVs. But to see it actually on a texture, you know, everything already unwrapped. No, I unwrapped it myself. Why do I choose OpenGL over Vulkan or DX12? I have an old computer, and so I can't take advantage of any of the good features that Vulkan offers. There would be no difference in me using Vulkan or DX12 or any more modern pipeline, because my hardware is a mobile 1050. So it's actually better for me to use kind of legacy APIs and things to make what I make. So that's my answer. But maybe one day when I have enough money, then I'll get a new computer and I'll do Vulkan and, you know, do hyper optimized, you know, stuff like that. But, you know, for now I don't really get to play with the shiny toys anyway. I basically am ray tracing against a UV though, but as I said, like, I don't know if you remember this, but when over here, I literally unwrap the textures myself. This is me opening a texture on the CPU and sampling it. And it's the same thing when I sample the cube map for the skybox. You remember we did this. I had to actually open the texture on the CPU and do it. So yeah, pain in the ass. It's probably a lot easier this way, but yeah. It was fun to do it because opening a texture on the CPU and doing the bilinear stuff yourself is kind of fun. But it is kind of a pain in the ass. Okay, so there's probably going to be 2 or 3 different compute shaders. Lightmap and init.conf. This is what I made earlier. Oh right, our bindless stuff. Our bindless stuff. Our bindless stuff has to get done. So the material GPU, I put this albedo emissive arm stuff on it. Is this aligned? 2, 3, 4, 1, 2, 3. 1, 2, yeah, this is aligned. Unwrap on the CPU and then rasterize normals and positions and things onto the UVs. That's what I do. That's what I'm doing now, yeah. That's what I'm doing now, yeah. But before, I did everything on the CPU, obviously. But my unwrap is always going to be on the CPU, yeah. Because of the complexity of unwrapping on the GPU is kind of pointless. But literally drawing it to a texture and then, you know, image storing on it is kind of cool. Like anytime I've done the image store stuff, like when I was doing my FFT stuff for the water, I was doing this like ping pong FFT image store thing. That was really cool. That stuff blows my mind every time I do it. you know. Anyway, so Anna, do you, every time you load in a texture, in a texture, do you automatically get a bindless handle for it, or do you do it later? You do it on a init, right? That's what I would assume. Yeah. Okay. I wrote this here. So let's do this when we do I think it's in load, where we have add image to registry. Actually, I think it's in GLTF where we do the stuff now. We'll make a thing for it later. Load GLTF texture. Add image to registry. Does this call load texture? Load texture calls the GL gen texture, so it should be here, I feel like. So it should return as well a handle. And also generate an image handle for an image. Store and load doesn't go well with handles. There are texture handles and image handles. I was doing the texture handle, I think. Is that what I'm supposed to do? It's kind of annoying that I have to manage two now. So now I have to get like a pointer and shit. I just do it after. And then put it on the image struct, I think. Put it on the image struct. Is this bindless textures? It is. I need bindless textures for the lightmap baking, unfortunately. I don't like to use bindless for other things because it's not supported on my integrated graphics card. But luckily I have the 1050 that I can run this on, but otherwise I won't be really using it, I think. Because on 620 it doesn't work, so okay. Okay, so we set that up, and now when we upload our material data, we want to get the handles. Matt's I have arm text and stuff like this. Diffuse text goes into images, so we're just gonna cast that. So that we can get our textures. I think it might just not be possible to write to a texture. Yeah, I'm not writing to a texture. I'm writing to the bound frame buffer texture, you know. That might be as me doing a fracture is apparently image source under the hood. In compute shader it is different, yeah. It is. It is different. In compute you have no like because you bind the texture in compute as like a special thing with a special with like a special format and stuff. Like it's different. There's a specific function that you call to bind a texture just for compute. I need to remember it. We shouldn't have -1 really, but whatever. I should have really just like gotten a pointer for this when I wrote this, but I think I just like did this super fast when I did this. So now we have to kind of pay the price. Oh no, I do. I get a handle for my default ones for sure. Or actually, do I? I don't think I do. For when I set up my default textures, my dummy textures. Oh yeah, I need to do this here. We need to get the handle here. We need to get the handle there. And so I need to go back to where I did the handle because I don't remember how to do it. Okay, there we go. Do I store it? I do, right? Okay, we do. On the wrong track. What I'm doing here is I am creating handles for the dummy textures that are when we don't have a texture for something, so that we don't have some undefined behavior. Yo, what's up, Rexon? I shoot rays using the G buffer from position normal. I have a G buffer now for the first time, which is pretty funny to think about. I'm not actually using it because it's, I think a G buffer is just too expensive for my computer, but it is a thing. Oh my gosh. Okay, well, it turns out that whatever. Don't be a fool. Like the Minecraft black and purple texture, exactly. And I have it for each component. Yeah, well, I don't think that your effects would run on my computer, unfortunately. I think that my computer would explode in suffering. But yeah, I've never attempted deferred, but for this you need a G buffer apparently for it. So we're making a G buffer for it. What the fuck was I about to do? I created these handles and I was going into the fucking thing here. That's where I was. Okay. And then I got distracted. Order of operations here. Arm. No, normal, you fucking loser. Sorry. I missed one. I'm supposed to get normal. I don't even think I have it. I didn't put normal on the handles. Fuck. Oh wait, images 0 handle doesn't work. I need to actually do normal, a default normal. That's where I store this, the name. Yeah. Default diffuse. Yeah. It is cheaper to compute lighting, but I literally can't do the heavy memory stuff on this because the driver overhead just fucking kills me. Like, if there's anything with too many drivers, you know, calls and shit, it's just unfucking doable. Right. I didn't put normal here. Never come back. Yeah, exactly. I have no VRAM. Doing this is gonna be hard. I don't even know. I'm gonna hope. We're gonna pray and hope. Eventually, I'll probably have to do these things in batches because I can't do like a full thing, I think. But that's what we're bound by now. Fuck. On the wrong track. Okay, that's that. So we set up our handles so that in the SSBO we have the ability to get the textures, right? That's how it works, right? So now our material, here's a question. Can you literally just, these are just the handles, right? Those are literally just the handles. It's just you call them sampler 2D, right? How does that work? You have an SSBO with them? The De Stefano GitHub, of course. This is the classic. Okay, this is like way more complicated than I'm looking for here. I want to see how he does it in the shader. Read-only buffer SSBO. Sampler 2D textures. How do you upload that, though, to the SSBO? Sampler 2D, UN64T. Yeah, but can I have... So I have this material GPU thing that has everything in it. So can I do, like, you know, Vec4 ambient and then still have this and then just call this Sampler 2D? Is that fine? I'm assuming that this map's fine, right? Because it's just replacing the 64T with that, right? I think so, right? I don't know. Look at Discord. Okay. Oh, I see. I see. Not sure if you can use sampler 2D direct. Based on this J Stefano GitHub, it says that you can just have an SSBO with sampler 2D textures. All of them require that you pass in the 64-bit handles as the SSBO data. So yeah, this is absolutely legal, I think. So I think that this is legal. I need to change this in our other shader though, don't we? We need to change this. Because, you know, we've changed it now. On the wrong track. Apparently, it's. I think it's equivalent. I think it should just be equivalent. Let's focus on one thing at a time. One thing at a time. I don't think it's faster either way. I don't think it should be. Is this aligned? Yeah. Yep. Sure it is. Sure is. Okay, I have to remember how we do all of this GL invocation ID things. I think that you just do that. We're gonna be doing it 2D though, which is kind of a pain in the ass. I think. We're just going to use uniforms here. Sure, it isn't like the fastest way. But it is what we're going to be doing. If x is greater than or equal to u lightmap width, or y is greater than or equal to u lightmap height, return. All right. Well, thanks for trying it. I don't think that bindless is it? Okay. I hope that it's supported by my GPU. I really do. I really do. Because this actually is not doable without it. Let's try this. Let's try to just compile this and then see if we get an error. I think it should give us an error. Let me just go to where I think I have This gives me all the arrows and shit that I need. Oh, I already have it. Okay. I think it's legal. Okay, good. I don't think my shader programs could be compute shaders, so for now we're just going to have them as yeah, I mean, you learn something new every day, including about GL half floats. I had no clue half floats were a thing. That was fucking crazy. Half floats like zero. No, you misunderstand. The 16-bit floats. You know, the ones that don't exist. That's what we did yesterday, remember? It's like a lower precision. It's like a lower precision, but it doesn't work at all. No, that's what I use for my lightmap now. In my opinion, you're... Sampler values, dynamic depth frag. Uh-oh. Oh, no, I didn't have bindless texture require. Fucking, where is the shader, bro? Come on. It may be completely cooked. Okay, I think we're golden. I think we're golden. We're golden. Oh my god. We compiled it. Holy shit, that's a fucking weight off my chest. Jesus Christ. Oh my god, that's a weight off my fucking chest. Holy shit. Alright, I need to know. I gotta know. Okay. I need some fucking... The problem is... I don't know what the max local size for this is, but this is what we're gonna be doing. This is the bread and butter. That's the bread and butter. I don't know how much this can be. It's weird. It's fucking weird. It's fucking weird. Let's just say that. 2D dispatch compute limits. Usually up to 1024 for individual dimensions. Common 2D local sizing 32 by 32 or 16 by 16. Make 2D local workgroup dimensions of multiples of 32. Okay, we can try 32. Compute, compute, compute. This is the name of the stream, except it's happening 4 hours in. Dustmite, you're a fucking liar. How dare you? What the hell is wrong with you, bro? We've been here for hours. Don't worry, I'm right here with you, bro. I'm right here with you. Okay, we need to move all this stuff, I think. I'm just trying to figure out, do we need everything in this one? I don't think that we do. We just need the albedo, because this one we're just shooting shadow rays to the light sources. This one is just the init, so I don't actually think we need the tri data. I don't think we need the mesh, or do we? We need the matrix. We need the matrix to do the transform. Yeah, we need the matrix. So we need this. Oh, we need everything. Oh, we need everything because we need to check occlusion. Oh, we need everything. Oh, we need everything. Oh, no, oh, no. We need everything. So we're gonna fucking put everything there. So, okay, here we go. That's one SSBO, and we have 5 more to go. So, okay, so starting with the 4th one, with the vertex, we're gonna call it data. And we will call this material data because that's my naming convention, and my naming convention fucking rocks, bro. It fucking rocks. Base stream, thank you. Thank you. I appreciate that a lot. The good thing is that, really, I mean, it's really not that bad. It's not that bad. There, we already did one. Not bad at all. We already did one. Now we just need to do the other 4. Try data. I don't want to call it no. We're not calling it a triangle. We're calling this a face because we're grown-ups here. Tries. Don't ask why. Don't ask why. I just think it looks better. So, fuck you. Okay. Wait, UVec3. Oh, right, we made that type. Actually, why am I doing it like that? Why the fuck would I do it like that? Okay. This is just a uint. And all of these are uints. Look at that. Alright. 2 down, 3 more to go. We're fucking knocking these out. The good thing is that we just do these once, and then for the other 2 compute shaders we're gonna need to do, we just fucking copy it over. And these are technically mesh nodes, okay guys, so okay, we're just gonna call them that because that's what they are. So It's going to be hilarious once we get this done, and once we do a light map. It's actually going to take like 10 seconds to make a light map now. I just had to do it because I got fucking embarrassed by the Sponza bake. And now we're just gonna crush all the bullies at school with this one. You know what I mean? You feel me on that one? Okay. We have no type def. We have no type def here. That's a C thing, buddy. This isn't C. This is a compute shader. Okay. I'm just kind of like blacked out doing this right now. I feel like I'm probably going to make a mistake. Because I'm not really paying attention. I'm just kind of yapping. And this is not a mesh node, this is a BVH node. Not mesh nodes because we already have that. This is a mesh BVH nodes. Okay. Holy fucking shit. Alright, one more, fellas. Actually, we don't need another struct. It's just the scene BVH data. And that's 8. And there we go. Holy shit. Look at this. Fucking 130 lines of just straight up structs. Excellent, guys. Excellent. Excellent. Excellent stuff, guys. Excellent. This stream has been literally 4 hours of me just trying to get the fucking data onto the GPU. Like, this is cursed. Okay. We haven't actually done any of the code yet, so we've been just like mentally preparing for this moment. Okay, so something interesting here is this texel list. Okay, let's make a note here. Implement a texel list how would I do it? It would have to probably be an SSBO. It would need an upper limit though. It would need an upper limit. Yeah, you couldn't unsize it. Yeah, this is tough. So basically I have this texel list here. So this texel list happens per triangle. For a mesh node, it happens per triangle. And what it does is it just keeps track of all of the texels that are on that particular triangle. And it's used for our blurring later. That's of course kind of tricky with what we, have now. The idea is that when you blur, you don't want to just blur, into the fucking padding, right? And so the idea is you keep a list of texels that you then you know, and therefore, you know, like the adjacent triangles on the adjacency map are searched, and their texel lists are what we iterate over when we blur. So I don't know how to do that with this. You could just say like a triangle has 64 texels that it can have on it. That's like a good upper limit, and then you just have this. Because like if you have like a giant fucking, like technically if you had like a triangle that's like the size of a building, obviously this wouldn't work. But I don't know. I'd probably have to look it up. I'd probably have to ask Jarvis this question, to be honest, because I'm not sure. Actually, I might do that now, because I don't really know how to do this. If I get rid of this texel list, then we don't have a blur. I'm gonna ask Jarvis. I'm asking Jarvis. I have a texel list for my light mapper per try that is used when blurring when I walk the adjacency map recursively. Is the only option to set an upper limit in an SSBO for it? Let's see. Just mask with different variances. No, you need to go over different triangles. You need to be able to map over different islands. Okay, it says that I should just dilate. It says that I should just dilate and then blur. So yeah. It's kind of a pain in the ass, because whatever, I have to write this extra thing now, but yeah. That's how everybody else does it, is that they dilate and then blur so that they get around that. But the cool thing about my old blur is that it was spatially aware. It was literally spatially aware of where it was in world space, and therefore when it was like for example, in your hallway, when you were in the hallway with that, next to the window, and the triangle is over here but you're over here, the cool thing that I had was it was edge aware, right? And so it wouldn't blur over the corner. So the blur was really the best part about the CPU light map baking, because it was edge aware, and like 3D space aware, right? And so now it's not, which sucks. What's up, Assassin Ninja? Which kind of sucks, right? But what can you do? What can you do? Not much, apparently. Anyway. What am I making? I am porting my CPU lightmap baker to the to the GPU. Bake an occlusion map somehow for it? Probably. There's probably some way to do it, but it's definitely not going to be trivial. Definitely not going to be trivial. But I don't think that I should have to do any of this. According to Jarvis, I can just do dilation for what I'm doing. But whatever. I still have to do all of this shit though. That's the thing. The good thing is we already have our position, and our position is pre-multiplied now. Do I pre-multiply it? Yeah. I already translate this into world space when I do this. How do I read a texture from here? How do I read a texture? Read texture from compute shader. I've done this before, but I just want to see really quick. Texel fetch or image load? Texel fetch or image load? Which one? Do I use texel fetch or image load? Use image load if you need to read from a texture that you are also modifying inside the same shader. No, we just need a texel fetch. Okay. How do I texel fetch though? Because I've only done image load before. How do I bind the texel fetch texture? Declare it as a standard uniform sampler. Uniform sampler 2D. Okay. Okay, so there we have it. Struggling with leak code? Yeah. Lightmap pause text, lightmap normal text, and then you lightmap ID text. Those are our three textures. So we want to get the vec3 pause equals, and then we texel fetch, right? Oh yeah, you can do this apparently. Okay, so you can do this in one line. So let's just do this. You can just cast this to ivec2 with the swizzle. And then this is texel fetch like this. And then you put in LOD 0 for base level. Okay, got it. You lightmap pause text chord and 0. Okay, and then we get the normal. And then IDs. Okay. Okay, so you apparently just bind it like a regular texture. You just bind it like a regular texture. Hopefully you can do it with UVec3. How fast do I type? I'm not sure. I used to type it like around like 90 to 100 words per minute. But I don't know really. But I feel like programming is kind of like a different thing than just like typing words, right? Like it's about like the speed of like the APM rather than the, like I make a lot of mistakes, but I also, you know, I'm kind of like, I have like a flow, right? So we already have all of the initialization stuff for the texels, right? We already have the normal. We have the mesh node, all of that. And we have the UVs, right? The UVs technically should be... Oh, we need the UVs. Oh, we need the UVs. For the texture. We need the UVs. Oh shit, I didn't think about that. Because we need them interpolated like this, in the same way. We need to write them to a texture, the UVs themselves, I think. Because you want to bilinearly interpolate like we're doing with the barycentrics here. So we also need AUV. Yeah, I knew we weren't gonna get it on the first try with this shit. I knew it's too good to be true. Too good to be true. On the wrong track. We'll always love you, but that's not the point. Okay, I think I did that correctly. I think so. Anyway, focusing here. Don't be a fool. Okay. So we get the AUV. We want the out vec2 VUV. Classic VUV shit going on. And we need another texture, right? Well, we could technically use it on the same texture. How cursed would it be if we had the last, the alpha channel of the position texture and the alpha channel of the normal texture were U and V? Would that be cursed? Would that be cursed? I think I'm gonna do that. Don't be mad at me. Listen, I don't make the rules. That's so cursed. That is so fucking cursed. Holy shit. That is so cursed. It's just packing, yeah. That doesn't mean that it's right. That doesn't mean that it's right. No, it is an optimization. It is an optimization. It's just cursed. It's just cursed. Like it, you know, like it's even if it is the right way to do it. It is. But that doesn't mean that it's, you know, it just feels a bit stupid, you know? You get what I'm saying. You get what I'm putting down. Like this is a bit funny. It's a bit funny. It's a bit funny. It's a bit funny. Okay. Lock the fuck in. We gotta lock the fuck in. Okay. Let's go back to what we're doing here. Okay, so now we gotta sample the albedo, sample the emission. Okay, everybody, we're sampling. Okay, lock the fuck in. Have to figure out how we're doing this shit. Okay, lucky here. We have ID is material, then mesh, then try, and so in IDs .x we have the material, so we can get the material mat equals materials IDs .x. Fantastic. Listen, I don't make the rules. It's fantastic. Okay, so let's get the vec3 albedo equals the mat texture 2D mat dot albedo text UV dot RGB. Yeah. Right? Albedo text. Or do I wait, do I even need to do texture 2D? Do I even need to do texture? Yeah, I think yeah. This is how you do it. Yeah, for sure. No doubt. Okay, so we have an albedo. We want to get the vec3 emission equals texture mat dot emissive text UV dot RGB. Okay, that one comes free. And you want to multiply that times the mat dot albedo mat dot diffuse. You know, we'll just leave that out of it. Because we'll leave it out. Can multiply by factors when we aren't scared they might be 0. Okay, we're just gonna remind ourselves for later. Okay, so this is the part where we solve the light source. Right, we need the lights. You're so right about that. We do need the lights. The light needs to happen. How do we get the lights in here, bro? How do we get the lights? You know what I just realized? That we have no fucking distance to the lights to occlude. We'll just compute it on the fly because I don't give a fuck. Okay? We're not gonna worry about it. We're not gonna worry about it. Don't worry about it. Stop freaking out. We're just gonna compute the distance on the fly. Okay? You know what I just realized? This material data is not 0. Sir. Sir. This is not 0. You're staying in your lane, buddy. Compute distances. It's more expensive to compute it when you're baking the fucking light map. Because let's say you got a point light, bro. You're doing worlds of it. Yeah, but you can pre-compute the distances since this is all static geometry. You can just pre-compute stuff, all the distances, so that you don't have to solve it per texel. So that each mesh already knows how close it is to everything. Millions of distances every frame. Yes, but it's slow. But it's an optimization to just pass in. Like what I have for my lights already, every mesh already knows how close it is to every light before I go into the draw call. You get what I'm saying? They get past instance data that already knows how close it is to every light, so that it doesn't do it per fragment, so that it determines if it's even in the distance of light. You get what I'm saying? So it's like a thing, because if we get a mesh here, it would be in like an SSBO which like has its lights, so that it knows which lights it needs to compute and shoot rays to. Because otherwise we're shooting rays from every texel to every single light source. Every single one. So yeah. Bit fucking cursed, if I may say so myself, but we're just gonna do it anyway. We don't have a amount of lights. Let's just take that in as a uniform. We're just going to do it simply like this. Okay. We just multiply by albedo after, and then add the emission, right? So lighting equals times equal albedo, lighting plus equals emission. Right. You notice how I skipped over the thing in here. Well, I skipped over it because I don't want to fucking write it, okay? What do we need to pass in here? Man, I wish you could have pointers. Can you have pointers, or is that illegal? That's illegal, right? I've never seen anybody use a pointer. But like, dude, like, I want to use a pointer here. Like, let's be so real here. I want to use a pointer. It's a fucking problem, bro. Mad that I want to use a little pointer? In slang, it's illegal? What? What the fuck? Is the GPU really copying these values or not? I don't think it is, so I don't think it matters. I don't think that they're copying these values. I don't think that's how it works. So I think we're chilling. I don't want to write all this shit here. That's not gonna happen. We have to make functions, bro. Just pass in. No. We want to fetch that shit once. We want to fetch that shit once. Oh, but we just pass it in to do this. So just literally pass in the IDs. Okay. I don't really remember what this shit is, but we're just gonna do it. And then this is how we determine if we're in range. I don't remember what minimum light visibility dist is. What the fuck did I just do? Sir? 0.1. Okay, we're getting into it here. We have to. We need the inverse dir for the slab test later. PP is funny. That's funny. The fuck is wrong with me today, bro? I've like cracked out of my goddamn fucking mind. All right. Get the inverse pause. I know some of this shit I don't actually use. We need to get the so this is the part where we go into mesh nodes and we index it by the IDs.y, and then the inverse pause we do the we do that inverse matrix times the vec4 of pp and 1.0 because it's a point, right? That's the right one, right? That's the right one, right? Yeah, yeah. No, it's, yeah. No, it's, yeah, yeah, that is the right one. And now we have to ray traverse scene BVH lighting on the GPU. Alright, alrighty. Okay, let's do it. Let's fucking do it. How the fuck are we gonna do this? How the fuck are we gonna do this? Oh, you got smooth reflections, that's nice. Smooth transitions, that's nice. How do you manage it? I don't want to do this. Holy shit. What did I get myself into? And instead of outputting whether we hit something, I just output that. Or we failed to hit, it's just 0.0. Oh, I see. Yeah, that's nice. Okay, so to traverse this without recursion on the GPU, we need a stack. We need a stack. So we're gonna have an int stack to some value. We'll have it at 256. We want this to be the scene stack, and then we'll have an int mesh stack. I don't know what the best value for it is, but just keep it at 256. The idea is when you traverse down the tree, you just push them onto the scene stack and the mesh stack. And we'll start at 0. By the way, this is the first one of the shaders. This is the easiest one. So this is the easy one. Okay. So yeah. So while scene count greater than 0, in the beginning we will set scene stack 0 equals 0 scene count plus plus. I just pass in scene nodes, right? The first one is always the topmost parent, so that's good. So we set scene stack 0 to 0, and then scene count plus plus. So you pop it off of the stack, right? So scene node, no, I didn't call it scene node, it's bvh node n equals scene nodes indexed by the scene stack scene count minus minus. Alright, peace out. I called it scene nodes, right? Scene BVH nodes. Yeah, scene BVH nodes. You can have this within here, it's fine. And then in here we process the node. And how we process the node over here is we do the ray intersection test, and then if so we return false, right? Let's do that. That's like an easy win for us to do, right? Is just to do the slab test and figure that out. Let's just call it what it is. Slab test. This actually stays the same. This AABB. Let's just call it pause and the inverse dir. This AABB type, don't we have this? Yeah, we have this. It's min, max, center, extents. Luckily enough, we can pretty much just copy this straight up. We of course are going to have to change the syntax a little bit. You could probably write it in a much more pretty way than this on the GPU. You could probably make it very pretty. All the mins. Yeah, whatever. I mean, you could probably make it way more friendly. We're not going to worry about it. We're not going to worry about it. We need to take in variables here. We need to take in the what do we take in here? We take in the origin, the dir, the inverse dir. Origin and the inverse dir. And the origin is the pp. Origin is not inverse pos. No, it's the pp. Okay. Let's just do this first. I like doing the GPU code because it doesn't yell at you with red lines all the time, like, hey, you did this wrong. Hey, you did this wrong. It's like, actually just lets me fucking finish my train of thought, which is quite nice. Although it does make me make mistakes sometimes, so that's also a problem. So we pass in the AABB for the node. So instead of this, if not slab test, continue. Then it's a root. Dude. Okay. If you go with that fella, you'll never come back. No. In my opinion, you're on the wrong track. So if we're inside, then we want to go through all of the nodes that are inside of it. So that means all of the mesh nodes that are within it. Right. And we made a thing specifically for this. We made a thing specifically for this, where when we get the mesh node stores inside the actual mesh node, right? So it's actually it's a little bit complicated. So to get the mesh node, we have to go into the mesh nodes and then index it by the mesh nodes, which is indexed by I plus the node dot first index. And then this is dot, what did I call it? BVH index. So it basically redirects to the right one so that we don't resort them. Okay. The first index is what I called it, right? First index and count, yeah. So that gives us the mesh node. And now, if it's a static mesh, do I have that data? I don't think I do. I don't think I do. I need to have that. Because I only have the mesh nodes and not the meshes. I need to know if it's a static. Because if it's not, then we don't solve for it. So this has to have is static. And so we need to make that change now. Mesh GPU is static. And we need to go where we upload it. Never come back. We upload it here for the mesh data. Oh, wait. We calc this, right? Okay, so if it's calc to 0, then we don't have to worry about it because it's calced. Therefore, we can check right here for each mesh node if mn dot is static equals 0, continue. Beautiful. Why is this so complicated? Why is this so complicated? What do we actually use here? Inverse pos and mod dir. Inverse pos is what we pass in here, right? It's PM. EM. So we do use it. So we need to get the really, we don't have to load it. Well, we're gonna load it anyway, so who cares? Does it matter? It does. We use origin here. Origin is the same as PP. Okay, now we call ray traverse and mesh BVH lighting with this. Do I ever use origin here? I use origin here, but origin is actually PP. Right? PP is an inverse pause. No, yeah, origin is actually just PP. And then we use PM to check for the slab pause there. PM is passed in. Yeah. So PM is this one. I use the original dir here. So it is important. I'm just looking at everything that I use and making sure. I use mod dir here, and that's MD. Inverse pause is PM. Do I ever use origin here? Oh, I do with this. Okay. Okay, luckily this function is going to be effectively the same as this function. So we're lucky about that. We're lucky about that much. We're gonna put a PM in here. Actually, no, PP PM. And we have the original dir and then the new mod dir. And that will give us a ray hit out, right? Aren't I supposed to be... Can I just have this as a global? Because I'm supposed to be... Yeah, I think I need to have it as a global. The ray head thing. Let me see. Let me look this up. Okay, no. Google AI Overview AI. Okay, so it says to not put it as a global and to just put it within scope, and then just continually push it back, push it back, push it back. But that, I feel like that's a lot of copying since it's a struct. Because you need to copy it up the tree then. If it's a struct, and I don't want to avoid copying it, return from the inside of the tree would of scope be optimal? Is it optimal? Oh. Wow, that's the first time I've ever gotten that. Wow, that's the first time I've ever gotten this. I asked Google AI Overview a question, and it just gave me websites. And none of them are related. That's crazy. That's crazy. I'm just gonna make it a global. You know, so because I don't want to write to it, I would have to return array hit here and then copy it every time I go through an iteration, which seems so expensive. I'm gonna try and avoid it completely. I'm just gonna try and avoid it completely, and if that's a problem, then so be it. I tried. This one's actually gonna be PM this time, I believe. It's a inverse pause. Yep, that's PM, and the MD. In my opinion, you're on the wrong track. Okay, so we go over the node count here, but obviously we're not going to do this. Instead, we get a face, and we index it by tries once again, tries I plus n dot first index dot bvh index. Double fetching. I know it's expensive, but it's better doing it this way than having everything ordered incorrectly. Here I continue, I do hit occluded equals true and then continue. Do I have that on hit? There's some extra logic that goes through here, yeah. So if mn.id equals the original mesh and the original try, the original mesh and the original try, I'm gonna leave this for later. It's not really extremely necessarily. To get PA, PB, and PC, we multiply by the matrix. Dude, I feel like what would speed this up so much, just like in terms of speed here, would be just like for each vertex, just have a transformed position and a transformed normal to test against. In fact, that's what I'm going to do right now. I'm just going to transform them on the CPU once and then upload them. And that'll be it. When I upload the points, I'm just going to multiply them once. And so this is going to look a bit differently. It's more VRAM, sure, but it's so much cheaper because we're doing this within recursion, you know? This is going to be so much faster. In fact, you know, if we want to be less lame about this, we can get rid of some padding here. I need the mesh node here. Oh, fuck. Oh, fuck, the vertices aren't for the mesh node. Oh, shit. Oh, shit. Oh, shit. Oh, shit. Oh, shit. Okay. Never mind. Never mind. Oh, God. Oh, God. Oh, God. What can of worms did I just open there in my mind? Okay. We're not going to do that. I just got really tilted thinking about that. Okay, we're not going to do that. We're not going to do that. No, because that's per mesh data, not per mesh node data. Oh. Yeah. Yeah. That's a bummer. That is a bummer. Well. Let me look this up. Does passing a unless you use the in-out or out keywords. What are the in-out and out keywords? Is it a pointer? What does that mean? Oh, man, this is a headache. I think I'm just going to copy the mesh node ID rather than the actual mesh node struct. But then we have to fetch multiple times. But, like, I don't know. Like, this is fucking stupid. Hold on a second. This isn't right. Right. The mesh node has a node offset. That's what we need to use. We need to use the node offset. Yeah, just pass in the mesh node, I guess. Fuck. I'm getting really hungry, actually, so I need to eat. I need to eat so bad, and I need another coffee. How did I do the indexing here? How the fuck did I do the indexing here? These have the vertex offset built into them. MF indices have the vertex offset built into them. Is this, can we trust this vertex offset? I think so. But the nodes don't. Is that a mistake? I think that's a mistake. Oh, but then that... You have to do this. Alright, this is fucking really getting complicated. This is really complicated. Wait, but the nodes have triangles, so this is actually the... Alright, I need to get something to eat. So, I'm gonna take a break. Okay, I just got really, really dizzy, so I need to fucking take a break. I'll probably be back in a sec, but... Alright. Yeah, I need to... This is really, really breaking my fucking brain today. The offsets are just insane. It's just really, really intense, so... Alright. My coffee's still dripping. Oh, man. Whatever the fuck this is that's going on. Nah, man. Like, what the fuck is this? Like, seriously. Like, what the fuck is this, bro? Like, what? What offset did I apply? What offset did I apply here? What offset did I apply here? I applied one. Here, right? Plus mn node offset. I think this one you have to apply though. Yeah, this one has to be. You have to have the node offset for where it starts, yeah. So this one you have to apply. But everything else should be baked in. Everything else should be baked in. Like this, the indices have their offset. And fuck is this BVH index? Oh. Right. That's what this is. Holy fucking shit, bro. My brain is like hurting. Like, oh my god. Like my brain is aching. Like my brain hasn't hurt like this in a long time. Like it like actually hurts. Like I'm like seriously like fucking out of it. Holy shit. Like it's just, there's just so much like pure coding to do. It's like there's like no break. It's like Jesus, like fuck. Alright, I needed to get the points. Right, but now it has the offset, right? So was it vertices? Is it what I had it called? Yeah, vertices. So this is vertices f dot indices 0 dot x. Dot pause and then 1.0. And then you just do that for the other two. So we translate them into real space, and then we just have to do the ray intersection test. I think that this is what we have to do. This is from the old engine. This is very, very old, but this is basically what it is with the barycentrics. So we need this as well. The good thing is that once we write these functions in the second compute shader, the bounce one, we just are going to copy the code, so it's fine, but out T and out hit point. Do we even, we do need the out hit point eventually. I mean, right now for this we don't, because we're just determining a conclusion, but Yeah, it would certainly be nice to return something that wasn't a struct, you know. Yeah, this is the first time in a while that I've been just completely, like, I don't know, just completely fucking out of it. Like, holy shit. Jesus. I think I do need the barycentrics eventually too. So at this point, you may as well be returning a ray hit. That's just like a lot of data to be copying. But whatever. That's out.hit, right? Out.hit equals false, yeah. That means the ray hit should have berries eventually, so what the fuck is that? I guess it's that. Is origin is PP, right? But yeah, PP is the original. So I think that we're good. This dir that we passed in is the same as the original dir, right? Yeah. I need to get my coffee. I'm also gonna get a snack because I'm like really I'm like hungry, my stomach is bad. I'm like, God, it's been 6 hours. Just so overwhelmed with this today. All right, second. I mean, at this point, you might as well write this, right? So if the dot of problem here with this, oh, you are doing that. So for now, we'll always be check normal. So you know what I just realized? We aren't transforming this shit. We don't transform it. So this check was always wrong, and I it should already have hit.hit equals true. If current hit.hit, if not current hit.hit, continue. That should be it. The barycentrics it already has. The posit should already have the T it already has. I don't think we need hit static because we aren't checking for dynamic. I think I wrote the code. Okay. So what do we do after this? Bro, do I play any games? Not really. We did when I was a kid a lot. Occasionally, I'll go through a period where I play like a bit of League or whatever, because I still like keep up with like professional League. It's like the thing that I do when I go to sleep is I just fucking watch the newest League games that are being played. When I do play games, though, it's like a playthrough. You know, like the last playthrough I did was of Wizardry 8, and I really like that. Like, I'll go through and I'll just play like some of my favorite games, you know. But I don't really do it very often. When I was younger, I played a lot of video games. Yeah. So here we want to initialize the hit.hit equals false, and hit.try hit.t equals infinity. I don't know if you're allowed to do that in GLSL, but I think there's a reason for hit.try equals 0. I'm not sure, but yeah, we want to do that, and then we just call traverse scene BVH, and we call it with pp inverse pos dir and inverse dir. So this is pp inverse pos dir, which is L, and inverse dir. And then if L dot light type is 1, else if hit dot hit return vec3 0 0 0. If hit.hit and hit.t is less than the square root of d2, return 0 0 0. Otherwise we return the light. And that is the compute shader. And we've solved the light source. Zig cell for Linux, measured in bytes, from the Zig Reddit. It gives me hope every time that the fucking algorithm misses. You know what I mean? It's like, yeah, he loves Zig. Let's get him Zig. Like, let's get this guy some Zig. Okay. And now we image store. We image store. RGB at 32F, image 2D, lightmap text. How do I call image store? How do I do this again? Image store compute shader. Okay. That's the shader. So what do we do now? Okay, so before we do anything else, let's see if we compile. Is this my side project? I don't really have a main project. So I mean, I guess. Okay. So let's just work through the let's just work through the errors. 190. It's not going to tell us all the errors at once, of course. So obviously we wrote this like this is the correct way. Also said undefined variable origin, which is pause. So let's see what else we've got. Okay. In out after a type specifier 219. Oh, it doesn't let me say out. Oh, okay. So we'll call it out hit. Yeah, that makes sense. I was confused why it was giving me that that syntax highlighting for it. But now I totally understand. Oh, I didn't get rid of this also. There we go. Okay. Some implicit casts, it looks like. 274. Implicit cast to int. Uint to int. So that's not allowed. 292. Another implicit cast. Really, this should be uint, I think, so that's fine. Let's just make everything uints. Maybe not. Yeah, let's just. I mean, it should all be uints. The count, no. Oh, the fucking little cat is mad at me for not having my door open. I'm sorry, buddy. Implicit cast to vec3. So let's just swizzle this to .xyz as well with this. Dude, this fucking cat, just shut up. .306, yeah, took care of it. 314 take care of this. mnidx mnid. Let's cast it to a uint. And ID is not a member of struct mesh node. Oh. Then what is? Mesh node ID. I called it mesh node ID. Of course I did. Okay. Has no return statement. 268. Yeah, it doesn't have a return statement. You're so right. Just have it return void because we have the global. And I'm sure it's gonna tell me a bunch more that I need to fucking take care of. But I just saw that. It's a pretty obvious one right there. Let's just see. Implicit cast 314. Implicit cast to int. Okay, well, we should make them uints. Too few parameters, 366. Too few parameters. All right, I need to pass in the mesh node. .410 looks like the next ones. Inverse major mesh nodes dot inverse global matrix. I'm trying to do DSA, but I just can't stay consistent. My mind keeps wandering everywhere, totally unable to focus. What should I do? Any advice? I have ADHD myself, but I find that medication has greatly helped me stay focused. But before that, what I did was I would just, you know, not do, you know, anything else, you know. I think it's easy to stay focused when that's the thing, you know what I mean, what you want to really do, you know. Like once I started heavily, you know, programming to the point where I really like got, you know, deeply invested in it, I think like it was impossible to tear myself away from it really. But you know, before that, when I went to college for like music and literature and all that, it's really easy to tear myself away because I wasn't really ever truly immersing myself in it like fully, you know. And so my advice would be to fully kind of give yourself to it and immerse yourself in it, you know, because I think that that's where the real kind of joy of life is. Like once you fully kind of give yourself to something, and don't really hold anything back, you know. I think that that's my best advice I could give on that. But you know, maybe it's a bit confusing advice. I don't know. Undefined variable infinity. Yeah. Can I just put float max? Try is not a member of RayHit. Try IDX. Yeah, no problem. Okay. Undefined variable float max. Okay. So we're just doing that. Infinity in compute shader. No, no. float.max value. (1.0 over 0.0). How do I write infinity in GLSL? Dividing a positive float by 0. Okay. Sure. I don't understand why that would be the thing, but you know what? Sure. RGB is not destructive light. Oh. Yeah, L.color, yeah. Okay. Oh, implicit cast 477, 447, I mean. UVec 4 to UVec 3. Maybe I can't texel fetch. Texel fetch on UVec 3. I mean, the texture is UVec 3. Actually, I mean, can I texel fetch on a U sampler 3D? U sampler. Okay. Okay, so apparently you can do this, but you need to set it to a U sampler 2D, I think. Okay. Okay. So we have compiled. So I don't really know, I don't really remember where we were at after here in the bake. I think that you just do it here. We do have to set up the uniforms and bind the textures though, which is weird. How do I bind? I should stop looking stuff up when I have the code for it over here in my other code base. I have it somewhere where I where would it be? I believe it's actually in init, where I do the FFT stuff. Yeah, here it is. Bind image texture. That's what this is. So that's what we're going to use here. GL bind image texture. And it's going to be GL write only. And we will bind the, I believe, the lightmap texture. This is lightmap texture. Takes us to here. Is this actually the thing though? We haven't actually generated a texture for this before, which makes sense because we didn't actually have it on a texture before. Or no, we did. Where is that? Oh, it's in the actual lightmap data, isn't it? Yeah. Yeah, over here when we init lightmap data, I do this, and I do the texture here, but we want it 32F just to be safe here, and we will not be using bitmaps on it. I just want to be super safe here. So anyway, we gen the texture there, and so it's that LD texture ID that we are going to use during the bake. So it's going to be LD texture ID is what we're binding. And I forget what any of this is. Unit 0, texture, level, layered, layer. You're coding for 7 hours? Yeah, I coded for 12 hours yesterday. Okay. So, what else do I need here? This is the exact formula we're gonna use. So we want to call it, we're gonna use, let's just be safe and use ld atlas.width, ld atlas.height. Okay. And we should have the work groups at 32. I don't know. I'm assuming that this is how you do it. Possibly, I'm not sure. All right, so what are the uniforms that we need for this? I wish I could become like you. I don't know. I have a lot of problems for me to do this, sort of thing. It's not something that's like, I don't think that it should be, am I stupid? Why is it not coming up? I don't think that it should be glorified, I guess, Like, I have mental issues that keep me inside a lot and doing this stuff, I would like more than anything to be, out in society or whatever, But, there's, the definite benefits of, people coming in here and saying, oh, this, I wish I could be more like you or whatever, that makes me, that really does make me feel good, but, you're good, bro. Thank you. Am I stupid? Why can't I remember how to do this? I've done this a million times. Yeah, it's active texture. What the hell is wrong with me? I don't have the textures here. I think that they're lightmap pause texture. And we just do it for all of them. Map norm texture. I don't really remember what I called it. That was gonna bother me. Okay. Okay, if I did this correctly, this should do a thing. I kind of want to draw this texture to the screen. Just to test that we're writing data into it. I don't fucking know. Like for now, let's actually just like straight up do that. Let's actually just straight up just fucking do that. I know that we aren't rendering right now, but let's actually comment this shit back in. What is this? The fuck is this? In render, let's just bind the LD text during post-process instead of the main texture, and let's just render it to the screen. I mean this. Let's just do. It's gonna be in globals.sceneData.lightmapData.textureID. And let's just try and render it to the screen. Seg faults. Well, it's not a seg fault, it just crashed. Which isn't great, obviously. Let's start with GDB. Let's see if it's a CPU side thing. Okay, obviously no. Unknown target exception. Fuck. Okay. It's not gonna be easy. It is not going to be easy. Let's try something very simple here. Instead of solving light source, let's just go, let's just add a red color. Oh, fuck. Well, it doesn't matter. It works. Okay. So it's something inside of solve light source. We have to go, huh. You know what I just realized is that we don't actually... We don't actually have a way to tell if a texel is a thing or not. Okay, hold on a second. Can I have integer, signed integer, OpenGL, signed integer texture OpenGL. I sampler, pendant I, unnormalized size. Okay, so I think we should use an integer thing, an integer ID text, and then set it to -1 in the case of nothing. Just clear it to -1 in the beginning. Yeah, just clear it to -1. And the goal with that is that we will know per texel if it's an active texel or not, because otherwise we have no way of knowing what it is. So where are the textures initialized? Here. So it said 32i GL int. Why don't you face the facts? Upset. We fall apart. So instead we'll just do this. No need for uints anymore. Not sure why I did uints in the first place. IVEC3. Okay, but we need to clear it with ints in the first place, which is kind of fucking annoying, to be honest. So we need to clear it to -1s. So Can I do this automatically, or do I just have to? I would love to just do it automatically. I think you can do GL clear text image, but I think I had a problem with this before. GL clear text image. That is to pointer array of between 1 and 4 components of textile data that will be used as a source for the constant fill data. Wait, what the fuck? Why is this so complicated? Okay, well, I have no clue how that works. I was just going to GL text image with an array of -1s, and I think that that's actually what I'm going to do. So that's what we're going to do. What? Oh, what the fuck am I typing, by the way? Okay. So now we can hopefully early out here. Okay, and now our red texture, if I still have it, now our red texture should have the shape of the light map. Am I using NeoVim? No, I'm using Helix. It's similar. Okay, that's not good. That is really not good. That's really not good. Why? Why? Why does that not work? Well, shit. If I remove this, then it should all be black. If I cleared it correctly. See, this is the fucking problem. And I did change this to an I sampler, right? I did, right? Uniform I sampler. lightmap ID text. lightmap ID text. How do we fix this? Yeah. Oh, hold on a second. This is supposed to be an IVEC3. Fuck. Yeah, I'm not sure. I don't think that I'm doing anything necessarily wrong though. I think that I'm clearing it wrong. It has to be the clearing. So otherwise, I don't know. How about this? How about this? We just clear it like that. And get rid of the frame buffer. No. Just doesn't want to clear. Or it's not texel fetching properly. How about this? How about this? Let's try going back to 1516 because that's what I had it at before. Lightmap ID text. How about this? How about this? Let's hard code, just make sure that this can exit out and that we're not looking at a very small portion of the texture or something like this. Just make sure. Okay, so this is correct. The chords are correct. It's just the texel fetch is not happening. How about this? Let's see the IDs. Let's see this. Texel fetch not returning negative value. Is RGB 32i normalized? Will it not work? Let's see. Let's see what it says. Oh wow, it just didn't answer the fucking question. Bro. Okay, let's try something else here. Let's try oh, wait a second. Oh my god, I'm so dumb. I'm so fucking stupid. Oh my god, I'm so fucking dumb. This obviously needs to be ×3. What the fuck is wrong with me? It still should have gotten rid of some of it, though. It still should have gotten rid of some of it, right? I was only... I didn't clear it properly. That's... No, yeah, it's still not. Let's try RGB A32i. I don't know why that would matter, but... yeah, let's try. Yeah, at this point we gotta try anything because it's telling me that 32i should be fine. But it's not. Let me check. GLint is 32-bit, right? GLB. Oh, okay. Okay. Okay, so this is not the correct format. It's actually RGB integer. I would have never got that. So, thank you, AI overview, for enlightening me on that, because I would have absolutely never gotten that. I literally said the format that I was using, and it did tell me that that is. Yes. Okay. Perfect. Okay. Okay. Nice. Figured it out. It was a format mismatch with apparently you're not allowed to do GLRGB as the format. You have to do GLRGB integer. That's kind of interesting, but anyway, we should see now the shape of the light map. No, we don't. Okay, so now that's a problem. Now we don't see anything. Did I fuck something up somewhere? Like I always do. Do we write to IVEC3, we write this out. Material ID. Okay, so now there's this issue. A material ID. We get a material ID in. It's possible that the a material ID isn't correct. We didn't really try the material IDs first. So maybe we just try something else. Maybe we just try y instead. So let's just try y is less than 0 return. So, okay, no. Okay. Well, that's not great. How about this? For just 1 second, let's try writing the out material mesh try ID. Let's try just setting it to ones. It may be that that it really doesn't like that we did this to. Oh, I commented this out. Oh, I'm so dumb. I commented this out when we were testing things, and now I forgot to comment it back in. So that's just a classic mistake. Okay, that's still black. I think the reason why it's black, though, is because we clear color after it. I think that we have to do this here. Hopefully. What am I going back on? No, it's still black. Rose Tony Stark? Really? Tony Stark? And just to check really quick with if I remove this line, we do still render red, right? We still do render red. No, we don't. Yeah, that's what I thought. So why is that the case? Maybe I have to GL bind frame buffer 0. Because we're touching those textures. Why don't you use a regular IDE? Why NeoVim? It's Helix. I think it makes me a lot faster. That's why. Let me reread this. Do not support linear filtering. Yeah. Yeah, I think that I'm sampling it right now, but now we're not outputting anything. Let's just try image storing out like this and just not touching anything else. Just one step at a time. Okay. Now let's try this. Black. Let's make sure that, I guess we never checked if the frame buffer gets completed. Let me check that my syntax is correct on this. Making a frame buffer with 3 color textures. I want to make sure that my syntax is correct on this. This 0 may not be correct. Yeah, it says that this is fine for me to do it this way. I know for sure that I'm writing the outworld position, for example. I know for sure that I'm writing that. Let's just make sure that we are doing that and bind that texture instead. Lightmap pause texture, just to make sure that I'm not going crazy here. I think that we may not be writing to all 3 of them. See, this is correct, right? But let's check the second one. Let's check norm. Nothing. Why? Is there a reason why this would happen? Oh, right. Right. You need the draw buffers thing. Right after setting up and binding your FBO. Do you do this just once? I totally forgot about this. Yeah. So you go, you need a array of this, of each one. Where am I searching things? Just Google. Just Google. Yeah, I forgot about this. I don't do this very often. Alright, let's try it now. There we go. And that's the norm texture. And now let's go back to this and bring back all of this stuff. And let's just see if we did it correctly. Now we should see that same pattern in the negative space. I'm going to find variable mat. Should be red everywhere except for where it was before, and it's not. Oh, I meant 3. I think that's what it is, right? N, yeah. My bad. There it is. Yeah, it's red in the space, so that's exactly it. So now only what is actually on the light map is getting processed here. That's what we care about. However, that's not going to, I believe, solve the seg fault, the issue. If it does, I'll be very, very, very surprised. It's not a seg fault, it's okay, we didn't crash. We didn't crash. Let's try something here. I knew that this wasn't going to be easy, but okay. Let's try to get rid of some of these. Well, it's like type equals 1, right? That's what it is, right? My enum. Yeah, directional is 1. So I'm guessing that there's a hit. Let's try returning there. Nothing. I hate to just keep compiling randomly, but this is before any returns. So I need to know if the light is getting through. Okay. Why would it get through here? Why would it even go through there? It should be light type equals 1. Unless I don't upload the data first. That just seg faulted us. Okay. Okay, so I've just realized something. Okay. I realized something. We don't actually we don't actually upload lights. We don't actually upload lights before this. We don't actually upload lights, so I need to upload lights here. Before we bake. And now that doesn't solve the problem, by the way, but that does not solve the problem. That seg fault is deep within the code. Not seg fault, but whatever it is. There we go. So now we have the light. However, I think once it hits traverse scene BVH, it crashes. I wonder if it's the stack. The asset that we're working on right now wouldn't even have like a crazy amount of nodes though. Yeah. I don't know how the GPU does this stuff, but I'm just going to do this. Hey, what's up? It is what it is. Another 8-hour stream, yeah. Do I stream daily? Sometimes. And then sometimes I disappear for a couple of months. Let's get rid of the mesh BVH and then just try the scene. Okay. So that's just the scene BVH. actually. This needs to be 1 equals 0. Do I have this code anymore where I did this a long time ago? And this. Well, ni is greater than or equal to 0, and I did negative SP. And I set it to yeah. And I did this. When I added, I did I did plus plus. Okay. This needs to be exactly correct, or else nothing works. Nope. I'm afraid if I keep doing this, my computer is going to crash. That's usually how this stuff happens with the GPU. Hold on a second. And now, yeah, you can't do this because then you plus plus and now you're at 1. So you don't do that. What kind of game am I building? I have my idea of a game that I want to make, but I mean, I'm really just working on the engine. Fuck. I mean, this would be minus minus is the thing, but like, that doesn't work either. I could also get rid of the slab test and see if it's something in there, but I doubt that. I mean, this is just so normal. This is so normal. Scene count plus plus. We can just get rid of the actual traversal and just do the stack stuff. My God. You should just be able to do like scene count minus minus here, and then, oh no, but scene count has to be 1, because then you go down here. If scene count is 0, -1, now you've indexed into -1. So this has to be plus plus. And then goes to 0, index 0, plus plus. I feel like, I don't know. Undefined variable n. Oh. Yeah, you do need this. But this doesn't work. I mean, the thing is, the scene BVH should have enough. Should not have 256 nodes. If I have to go in and view them myself to guarantee that, then that's what I'll fucking do. But I don't know. It could be an infinite loop as well. But I mean, it shouldn't be, because my BVH is correct. We can check for an infinite loop. It is an infinite loop. Okay. Okay. Fucking Christ. How does my scene BVH have an infinite loop? Oh, fuck off. Oh, fuck off. Fuck you. Fuck, man. Alright, let's see where we upload it. Let us see where we upload it. Okay, we upload scene BVH GPU, BVH node GPU times the scene data BVH nodes count. We pass in S nodes. S nodes is calced to the BVH nodes count. And we iterate it, and we just copy in the exact values. The exact values in the same order. Yeah, I don't know. I mean, I think I'm traversing it correctly. I think there's something that I'm missing. There's something that I'm missing from my old implementation. I mean, I've only got like it partially here, so I only have like it kind of like in bits because it's like an old tore the code apart. I'm looking at the comments here to try and see. I feel like I'm gonna lose my mind here. Wait, hold on a second. Oh, hold on a second. I think I understand it. I think I understand it. Yeah. You have a separate thing. You have a separate thing. Wait, maybe not. Yeah, I mean, this is like an old implementation that changed into left and right pointers and not. This isn't the stack thing that I'm trying to remember how to do. I don't remember how to do this, dude. I don't know. I'm kind of like so confused. Oh my god, that worked. It worked. I needed to separate it. Oh wait, no. I have the safety on. So it doesn't count. No. Maybe take a break, eat something. No, I already took a break. No, that's not. It's not working. Let me look this up. I mean, this is exactly what I'm doing. This is exactly what I'm doing. Do I have... Uh... Can also learn? I like doing it on my phone because I don't have any control over what's going to appear on the screen, and I don't like, that. Let me see the acceleration, the tree walk that I do here. See, what am I doing differently? I'm not doing anything differently. Oh, wait. Yeah. Yeah, I need to slab test continue because otherwise we're always going to keep adding onto the stack and never and never pop off the stack. The root should always be at 0. At this point, I mean, I can just like do 1024 here and then see. I don't know. Settings to prevent, but still, yeah, I guess it's just, I just prefer not to. Fuck. Is it possible that there's like a namespace pollution going on? Padding issue. AABB. How about this? Let's not have AABB be its own struct instead of a struct. Maybe it's something to do with that. Maybe it just can't handle this. And we just do this instead. Let's just try that. Because, I don't know, I feel like I'm traversing it properly. All right. And when we initialize it, we need to upload it now differently. It's already yelling at us. We initialized the scene BVH before this, right? Yeah, we do. We do. We definitely do. Let's print the parents. I need to see exactly what it's getting. Fuck you. Let's see. It's gonna get mad at me that it doesn't have a fucking thing. Dude, seriously. What? I just need to see the printout. -1 parent 0 1 1 2 2 3 3 4 4. That is a healthy tree. They all have 2 parents. And the root has -1. So that's a perfectly healthy tree. Hold on, let me think about this. So if we scene stack, scene count, minus, minus, and then write into that God, I'm just, this is so confusing to me. Wait, hold on. If you start at 0, and you minus minus, you go to -1, and then you're indexing this into -1, right? So obviously that can't be correct. That's why you start at 1. 1, and then you do minus minus, then you're at 0, 0, plus plus. Yeah, it has to be this. It has to be this. I think I'm still alive. I don't know. It just DC'd. Anyway, it seems like we're one off. I don't understand. I don't understand. I don't understand how we're one off. This is like so strange. It says that I should initialize this at 0. I don't know. Maybe I am one off and I keep fucking and I keep fucking I should just do that, but like I already tried this. Yeah, this is no good. I already tried this. I tried setting this to... God, I'm so fucking... No. I'm getting in a bad mood from this now. Because this is like the most simple fucking thing ever. Okay, let's print out the fucking the children. Like at this point, I don't fucking know. I don't know, the tree has to be healthy. One and 10, 2 and 9, 3 and 8, 4 and 7, 5 and 6. This doesn't seem correct. This doesn't seem correct. One in 10 doesn't seem correct. I mean, maybe. But this pattern is so weird. 4, 7, 5, 6. I'd have to draw it out to see. Oh my god. I could try, like, writing the same code on the CPU and seeing if we get stuck in a fucking an infinite loop here too, or if it's got something entirely to do with the GPU. I don't know. I mean, it might be that our tree is bad, but like, then why is traversing it not, you know? let's just recreate exactly the code on the CPU and then see what we can do. All right, let's see. What? 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 See, yeah, this is what I was saying. It has to start at 1. You have to start this at 1. Or else you just reference garbage. You could start it at that, but then you have to do this. Right? Okay. Okay, so that... Okay, so let's just try that. Let's just try that. Exactly what I just did. Just do plus s scene count. And then you can start at 0. I don't know why it took me doing it on the CPU to come to that conclusion. But, yeah. Okay, there we go. I think that this is equivalent to how I had it before when I did it with greater than or equal to 1. This is equivalent, actually. It just seems wrong. But I'm just glad that that's fucking over. I think I'm going to keep this with the AABB not in a struct, even though it's annoying. Just because I don't want to fucking deal with that right now. And we're just going to pass in the node itself then to the slab test. Into the slab test. Okay, and so now we can go node. Yes, exactly. And now I just want to make sure that we are still able to traverse through this before we do the mesh BVH, because that's the even bigger BVH. Well, let's just make sure that we exit out cleanly from this. Okay, nice. Okay. Now, is it actually traversing? We have no fucking clue. Okay, so this one's the harder one. So we want to do greater than or equal to 0, and then minus, and then plus mesh count when we add. I think that you can do it the opposite way somehow, but I'm too stupid to figure that way out. So, unfortunately, that's the way it is. Okay. So we are enabling the traverse mesh BVH. And we will see what happens. We got through. The weird thing is that it looks the same. So I don't think that it's working. Oh wait, you're not supposed to do mesh count plus plus. No. Yeah, everything's white. Hats off, bro. Thank you. I might just check. There could be a million places where it's wrong is the problem. Like there are literally an infinite amount of places where we could have fucked up. How about this? Let's just not test the normals at all. Let's just go current hit.t less than hit.t. Hit.t starts at infinity. Like there's just no way that it's not, that there's not some occlusion, you know? There's just absolutely no way. I wish that there was. Actually, so this, let's just return red for stuff that we determine occluded. And I want to see. There is some red. There is actually quite a bit of red. There is. There is a bit of red. I mean, I don't know. I wonder, can we actually use this light map with the UVs and draw it to the screen and just actually fly around the world and use that as the light map? I feel like it's probably possible to do so. Yeah, let's try to actually just like render it and then walk around and then see and then debug it like that, because that seems like a way better, way to do things. So let's just activate the rest of our, regular render loop and try it out. In fact, I think that we were already rendering everything already. So let's just try that then. Why don't you face the facts? Okay, there's nothing. The fuck? Oh no. Why is there nothing? I don't call add all meshes to buffer. That's why there's nothing. See if Anna's model loads. It does. And this is our light map so far. This. don't see I don't see any of the red. I don't think that we're actually uploading the texture. So I think that we have to do that. I think so. No, maybe not. Maybe not. Fuck. Fuck. Why is that not working? Shit. We should always bind lightmap, which is lightmap data.texture ID. So we should always bind that, no matter what. So, yeah. That should... Oh, so this is... Okay. Damn. No, it's fucked up. Yeah. We are... This is not correct now. This is definitely not correct. Okay, so... Oh, also, I said I was gonna do red here, and so I just want to like make sure that it's not the BVH, you know. I just want to make sure that it's not the BVH, you know. And so I think I'm just gonna test everything. I think I'm just gonna test everything. Test every triangle, everything. Test everything. Let's see how it works. And let's just not let's just test everything. And we might be here for a while, but oh, it was immediate. The GPU works fast. This is the test against everything. This is what it comes up with. So, I don't really know where the light is coming from, but it can't be correct. This cannot be correct. Even if it was like, yeah, I mean, there's no way this is correct. There's just no angle for it to... The red is occluded, by the way. So, there's no way. There's no way that's correct. How do I do this? How do I check this out? How do I figure this out? We have removed the BVH completely. I think that this should be a normalized. It's not it's not like the craziest thing ever, but that should be a normalized, I believe. Let's see the original traversal again and walk through it again, I guess. Just walk through it just one more time. Walk through it one more time. Okay, so starting from the top, we create PP, pause plus the normal. And we get the normal from the texture, right? Normal text.xyz. The UVs are the W's, right? We know this. We use the normal. Okay, we get the normal. Let's try not biasing by any normal. Let's just try that as well. I wonder if our normals are wrong. I don't really remember how we upload our normals. We upload them per vertex and per try, and we bake them in here. We bake them here. We bake the points normal. So there's that. You know what? I just had an idea. What if we just bake the normal? Just to see. I mean, this will actually prove so much. Just to see if our unwrap is correct. This will tell us so much. Okay, our unwrap seems to be correct. Green, red, black for negative, and then blue on top. Yep, that is correct. So the normals are correct. So that's a pretty good vote of confidence for everything. Still doesn't work though. I am correct with the 1.0, right? Yeah. I'm correct with that. I don't really trust the 1.0. I don't really trust it. I'm just gonna set it to like some insane value. I don't know. I don't really trust it. And then we traverse down, and then we index into mesh nodes. I plus n first index. Dot BVH index. How about this? How about this? How about this? How about this? Yeah, it's tricky because we can't really not in the bake. It's in here. It's tricky because we certainly can't node first index, node count. Oh. There's no guarantee that the mesh nodes. Oh shit. Oh shit. Hold on a second. I just. Oh shit. Oh. Every mesh node needs to be in that order. Every mesh node needs to be in that order. And then you just per mesh just do it once. Just do the thing once. And so you just have a bool mesh processed. And we're gonna calc that to globals.meshes.count. And okay, got it. And then if not mesh processed mn mesh, then process it. But we have to have the exact amount of mesh nodes in mesh data, or else it all falls out apart. Okay, let's give this a shot. No, it still is pretty fucked. Still is the same thing. Oh, I never actually set mesh processed equal mn mesh equals true. I never set that. Oh, what the fuck am I doing? I'm surprised that that didn't change anything. Yeah, I don't know. We tried to not do the BVH index stuff. I mean, I feel like it's just that's just pretty scary to be doing, but we could try it. Technically, it shouldn't make a difference since we're traversing all nodes. If it does make a difference, then obviously. It does make a difference. Hmm. You know, I think that something weird is going on with the matrices, to be honest. I think something weird is going on with the matrices because because I just do. I don't know. Wait, hold on a second, hold on a second. The tries. Wait a second. We need an offset here. The nodes don't have offsets, do they? Oh, they do. They do have the try offset. The node first index does have the try offset built into it. Yeah, I don't know. Let's check the padding again. Padding looks fine. Yeah, I don't know. It could be a million things. It could be literally fucking anything. Just gonna do that there. I mean, that's obviously not this, but whatever. I do like, there is like a possibility. I mean, maybe we should try to, instead of keeping the inverse, do the inverse in real time. Try that out, I guess. At the end of the day, though, we're passing PP and dir down. MD and PM are only used for the slab test, so really the only thing that is really occurring is that the only thing I could think that it's is the this when I upload it to the draw buffers, indices, indices plus, yeah. So it's not like we already have that index, that offset baked in. Node first index plus try offset. Yeah. I mean, that's correct. It's all correct. And I mean, I don't even use this stuff. mn node offset. Yeah, I don't know. Yeah, I don't know. I feel kind of stuck now. I know for sure that the triangle data at the end of the day is incorrect. Somehow the triangle data is incorrect. Wish there was an easy way for us to verify that. What we can do though is literally just loop over all triangles, quite literally, and then see what you know. We could literally just debug, do all of the triangles, right? And then see. Let's see how many triangles we have, because you know we could pass it as a uniform technically, but let's just see it. Let's just see the try count. Tries.count. Let's just see the try count and then we'll just loop over all of the triangles and see. The try count is 708. Okay. So let's just loop over each 708 triangles and then do the ray test against it. Oh, but then let's just do 700 and just get the try there. The problem is we don't actually have a... We need to do this, right? But we don't have... we don't have... Does the face have the mesh on it? It does have the mesh ID. Is that mesh ID real? It's mesh ID. I need MN ID. I'm sorry, but I need MN ID. Let's just pass in. Oh fuck. No, we can't because of each mesh node. Because of the MNs has the actual fucking matrices. Oh my god, you piece of shit. You piece of shit. You piece of shit. Okay, so then we need to actually also know the mesh data. Let's just go over 12. I think that there's 12 for sure. And just go try count on each one. 12. Get a mesh node. MN. What the fuck? Mesh nodes I. Int j equals 0. J less than MN. Dot try count. Face f equals tries j plus mn dot try offset, and then just use this and then this. If current hit dot hit, return vec3. Oh, it's storming outside. Okay, let's try this. I think that we have 12 mesh nodes probably. Mat dir. What do you mean? Oh. L. Why Matt? I have Matt right here. Oh, I didn't do this. Alright, let's see. Oh. You know what I'm starting to think? I'm starting to think that this might actually... Is it possible? It shouldn't be possible. It shouldn't be possible. But what makes me think that it might be is like this, right? Like see through here, and then you've got like this small amount that isn't occluded. Like technically, like if we were all out here or something, like I don't know. Like if we were exactly like right here, maybe I could see it. I don't really know where the light is though, is the thing. I should really have the all of the lighting on when I do these tests, just so that I can see where the light is coming from. But I just looped over all of the triangles, did the matrices, and tested. Now the fact that it looks the same is so weird. I expected to see something different. I thought that it was on the triangle data was the problem. But I guess not. I guess my walk is correct. Like what? How is my walk correct? Meshes umesh node. That global matrix. Let's see if I did that correctly. Mesh node ID. And what am I looking up there? I'm looking up the matrix, right? Meshes U mesh node. And that's the same struct, right? I'm not incorrect there. That's the same struct that I use later for mesh node. Yeah. I have another one called isStatic here. It's the same though. How about this? How about this? How about this? Let's try using nearest instead of but you're not supposed to. It's supposed to be linear. How about this though? Let's try linear. Let's try a nearest. Just to make sure. That it's not that. Our normals are correct though. That's the thing. Our normals are correct. We've checked them. It's just harder to check the positions. Okay, can I fucking do the right button this time? Okay, let's try this again. I mean, it is like I expected, right? Like like this, right, is not occluded. This is not occluded. But then you got weird things like this part on the roof. That's occluded. So it isn't that. You sure that it isn't that? I wonder if everything even has transform matrices in this scene though. Yeah, I don't know. I'm kind of stuck. Yeah, but the normals are correct, and we do the inverse global matrix here, so the normals are correct. Then yeah. We should seg fault here or crash or, you know, whatever. We should crash. We didn't. No, we get the same exact thing. Is this green? Yeah, somehow the try offset and the try count and all that must be wrong. Oh, wait a second. Oh, shit. Oh, shit. I think I just realized something. No. No. That was definitely something though. But I think in this case, the yeah, every mesh has a unique node. So in this case, it doesn't matter. Oh, we can try to get rid of you know, the same try. The push out by the normal should solve that though. And we're sure that well, it's not even the inverse pause that we're using. Can I visualize the outworld position? Would that even tell me anything? That wouldn't really tell me anything, I feel like. I mean, we can try it. Let's try times 0.01f. Who's got this story? So this is yellow to green, then red on the back. It's hard to see because of the lighting. This is yellow to red. So we have clean gradients. Yellow, green, and then down goes red. I'm trying to see blue. Is there any blue? It's hard to see because of the lighting over here. Is blue up here? Yeah, blue is up here. And then purple over here. So the position is correct. Position is correct. Position is correct. The normal is correct. So that means that it has to be, there's no other thing other than it has to be the ray stuff. Let's try just negating L. Let's try just negating L. I don't know, like just negate it. Just to see. Okay. Now it just seems random, yeah. This is interesting. This being here is really interesting. This right here. It's like seems pretty targeted. I don't know. Fuck it, bro. Let's try the local matrices. I don't know. Just to shake it up a bit. Let's just try the locals, bro. Let's just try the locals, bro. Why not? Is it the same? Thing is, this is green actually. These are both green. It could be that we're somehow applying the transforms twice. I don't know how. Like literally 0% chance that that's happening. But we're just gonna forget that there's a 0% chance that that's happening and try this out. Yeah, like I said, I don't even think that it's a matrix thing. Okay, if that was it, I was gonna get so tilted. Holy fucking shit, I was gonna get so tilted if that was it. Oh my god, thank god that wasn't it. Thank god that wasn't it. Oh my god. Oh my god, I would have been so fucking tilted. I would have, like, literally, like, I don't know. I would have been so fucking tilted, holy shit. The thing is, this can't be really wrong. Unless the actual triangles are wrong. I'm just seeing if there's anything that I do with pointers where I'm reusing a stale pointer or something. Yeah, I mean, I don't know. Just anything at this point. Anything at this point to you know, get me out of here. Wait a second, wait a second, wait a second. Wait, no. I was reading the wrong thing. Yeah, I mean, this is the exact code. This is the exact code. Let's try. Let's try hard coding the light direction. Surprised I didn't think of that first. It's hard to tell if there's green on it because of the light. But it looks like it didn't change anything. Looks like it didn't change anything. It's important to remember that we are that we're not going all over all the mesh nodes. there is 18. So we can go over all of them, but I mean, it's like one typo here, and it's like the whole thing's fucked. Let's try that. Let's try asserting that the mesh node mesh ID is the same as each triangle's mesh ID. You can also do the same with the material. We should see blue, but I don't see any blue. So that's correct, apparently. Like, what the fuck? Yeah, I'm kind of tired here, but like I hate to leave it on such a bummer note. But yeah, I kind of just need to sleep, I think, at this point. Not to say that that's like the reason why I'm stuck here. I think I'd be stuck here no matter the amount of sleep I had, to be completely fucking honest. I'm gonna have to keep thinking about this. I don't know. Doesn't make sense. I mean, we've hard-coded the light direction. We're testing against every try. There's not much more that I can hard code. So it may be something with this ray intersects triangle test, that it's weird on the GPU for like whatever fucking reason. I don't fucking know. I don't know why that would be the case. But I mean, maybe one of these casts is wrong. I don't think so. And we're not even interacting with the BVH anymore. We aren't. I've literally just removed it. Could try vertex offset -1. Something we could try. Just using -1 for all of it. I don't know. Like, I don't know. There's a question there, you know? I don't know. I don't think so. Wouldn't really make sense if that was the case. Is this correct? Is this correct? Is it correct? It's hard to tell the roof because we have the lighting on. Let me see something really quick. Let's try moving this there. Maybe it is -1. Hold on. Let's go to here so that we can view things properly. And let's just view the map. No. No. It's closer. It's closer to correct. I mean, this is kind of rough, but yeah. It's weird because some of it's correct. Like, a lot of it is actually, it's just the roof pretty much. It's just this portion of it. But God knows why it would be that portion of it. It's definitely not -1, by the way. I just thought about it in my head. It's definitely not. Alright, I mean, whatever. Alright, I'm getting out of here. I will leave this to tomorrow, I guess. I kind of wanted to get some visual. You know, we did a lot of stuff today. You know, we did a lot of stuff. We got it rasterized. We got it to the screen, but there's some bug somewhere in my indexing, and there's a lot of code to go through to find it. So yeah, I'm kind of stuck. I'm gonna take a rest. So